about learning is that no one can take it away from us. Said by B.B. King, this will be the exact hearing and bearing of responsibility we will have today. With devotion to set our perspectives towards the success of international seminar on advances in design, construction, and operation of tunnels. Esteemed guests and distinguished members of our congregation, we extend a very heartfelt wish for a good morning. We, the DIT University Dehradun, feel honored to host you and this international seminar for the second day. I, Ankit Karmakar, sophomore DIT University, wish to congratulate all of us to have gathered here today again, and for that, I request our congregation for a heartfelt applause. Moving forward with our seminar, I would like to take this moment of honor to introduce the panel present over here today towards the direction of our seminar, which we'll be heading towards. Our session will be about risk management. In this session, we aspire to discuss about risk-based decision-making in tunnel safety, presented by Mr. Bernard Kohl, PIA Technical Committee 4.4, member Austria. Moving on, we'll be talking about implementation of safety management systems, an innovative approach dedicated to safe road tunnel operations by Ms. Helen Mongo, PIA Technical Committee 4.4 and ITA COSUF member, France. Next will be the presentation on impact of new energy carriers on tunnel design and safety by Peter Strum. I'm honored to declare the chair for our seminar and session 5B today, Dr. M. Parida, Vice President, IRC and Director, CSIR CRI, New Delhi. And along with him, our co-chair, Mr. Ingo Kondinya, PIR Technical Committee 4.4 Chair. I'm honored to have you as our esteemed chair at this event. Your presence has added a sense of grandeur to this occasion, and we are grateful for the opportunity to learn from your vast experience. I would like to invite you to join us on the high table and guide us through this event, sir. I thank all the dignitaries to join us. Distinguished guests, ladies and gentlemen, it is my privilege to extend a warm welcome and express our sincere gratitude to our esteemed chair and co-chair for giving us their time. Mr. Ananyabrata Maulik is a distinguished personality in their field, and we request to please come up and felicitate our co-chair and chair for this seminar. Thank you, dignitaries. With felicitation in place and everyone delighted, we shall proceed with this seminar, and for that, I now hand over the procession of our seminar to our respectful committee on the table.
Thank you, Ankit. Very good morning to everyone. I would like to extend a warm welcome to the co-chair of the session, uh, Dr. Ingo Kondinya, and three presenters. We'll start with Mr. Bernard Kohl, then Ms. Helen Mongier, and Mr. Peter Strum. So this session is on risk management. We started yesterday the discussion on the planning, design, construction, but risk is also very, very important. There are two parallel sessions. In fact, the other session is also dealing with the risk management. And out of the three presentations, we have one presentations on risk-based decision making in tunnel safety, very focused presentation. And second one is the safety management system for tunnels. For highway projects, normally we carry out road safety audit in India. Similarly, for tunnels, it has to be very, very intensive. The technology, the techniques, computational methods need to be very clear. And at this, the third presentation is going to be a bit interesting in the light of especially the electric vehicles, hydrogen vehicles. You have fuels with alternate kind of energy systems. So with that perspective, probably we need to look at the tunnel safety in a very different perspective. And just to introduce, I am currently director CSR Central Road Research Institute, and I'm the vice president of IRC, plus I'm chair of Urban Roads and Streets Committee. Specifically, the tunnels in urban areas, in metropolitan cities, are of interest to me. We have seen development of lot of metro systems in different cities in India. So there are a couple of them which is running underground, and the safety is very, very important. Besides that, you have many subways, you have many tunnels also that could be very useful for crossing the rivers in certain cities. So in view of this, this is a very important subject. And with that, now I request co-chair Dr. Ingo Kondinya for his remarks. After that, we'll have the presentations. We started a bit late. So for each speaker, we'll have 20 minutes, which includes question and answers. So it will be good if each of the speaker completes in 18 minutes, followed by some discussion. Thank you. So with that, I invite Dr. Ingo Kondinya.
Thank you very much, Professor Parida, for this introduction. I don't want to take time from the presenters, so I just want to say I'm very happy to have you all here in this session. I think it's a very relevant topic, risk assessment, and we have 3 very interesting talks about this, and I will be very interested to see how this will incorporate into things you are doing here in India. So please ask questions after all the presentations, and we will have a very active discussion, which would be very beneficial for this session. So thank you very much, and I think we can hand over to the first speakers.
Yeah.
Are you presenting?
No, it's already there.
Okay. So very briefly, Bernhard Kohl is presenting about risk-based decision-making in tunnel safety. And you had seen his biography. Briefly, maybe he's studied civil engineering, and he's working at ILF Consulting Engineers. And since 2020, he joined the ILF Group Management Board, and he's responsible for the coordination of the business area, transport and urban spaces, and also, I think, for international affairs. Bernhard.
Thank you very much, Ingo, for the kind presentation. Welcome, colleagues, to the first session this morning. I hope you are already awake, everybody. So I will directly start into the topic. I will give you a short overview on this topic, risk-based decision-making, to show why we need it and what could be the benefits. Let's start with a short historical review. For the Europeans, this is very well known. For you in India, maybe not so much, but around 2000, there were several big fires in European tunnels. The most famous ones are the ones in Tarbes and Mont Blanc, and there were significant consequences. And at that point in time, tunnel safety came into the focus of interest. And it initiated dynamic development, and one result of this was the European Directive on Minimum Safety Requirements for Road Tunnels, 2004-54 EC. And this triggered a lot of innovation in Europe, including harmonization and integration of the topic into guidelines, into the operation and the daily practice of operating tunnels. So on the one hand, the EC directive defines requirements, so it's prescriptive to some extent, but on a very general level, but it also implemented a modern safety culture. It means an integrated, holistic approach, new tools for road tunnel safety management, like risk assessment, which is my topic today, but also safety inspection, safety documentation, and the culture and the process of feedback from experience, which is very important to learn from what has happened. Now, a little bit of general introduction. What do we mean when we say holistic view on tunnel safety? It's important to mention that incidents that are happening are typically very complex and there are a lot of interaction effects. So that means you have to take into account all the elements which are influencing that, and that's not only the tunnel itself, the structures and the systems, it's of course the operation, the organization of the whole operation, it is the safety systems, but it also of course includes the drivers and the vehicles. So everything and everybody contributes to safety, and at the end you have also the emergency services. So and if you look more systematically on that, you have to cover all types of significant tunnel incidents, may it be collisions, may it be fires, and all aspects and elements of a tunnel system. What I show here is the so-called integrated approach, which shows you a flow chart which is more or less defining how you can address the topic in general. Typically you have prescriptions, so this is what we call here minimum safety requirements, or could be additional requirements defined in national regulations, which lead to some safety criteria. But on the other hand, you can also have a performance-based approach like risk assessment, which gives you, let's say, a more operational approach to tunnel safety, and which allows you also to introduce socio-economic and cost-benefit criteria. Because, of course, tunnel safety is not a standalone topic in the tunnel world. You also have to take into account the boundary conditions, cost, traffic, all these aspects which are relevant. And at the end, you have to apply this process on a new tunnel, but also on existing tunnels. So what you can see here in these circles, that of course after some time you have to review the tunnel again, whether it's still compliant, whether something has changed, and maybe you have to do something, you have to change something, you have to upgrade it. And then you again have to answer the question, is the tunnel system as it is safe enough? And this is how it is all about, and I think this is very useful. This is also shown in one of the PIAC reports I will be presenting later. The second principal approach I want to show is the risk assessment process in general. So this is how you conduct the risk assessment. Of course, you have to define your system. Then you have to identify your hazards you want to address. And when you look at the hazards, you have to look at the probability side with a probability analysis, and you have to look at the consequence side. And risk is always a combination of the probability and the consequence of potential incidents. And when you have, let's assume you have a quantitative approach. When you have calculated your risk, you have to assess it. So you need some criteria to assess whether the risk you have calculated is acceptable or not. And depending on whether it's acceptable or not, you have to implement additional safety measures, and then you have to assess the safety measures in the same approach. So this is how it works in general. Now, what does that mean? What does this European experience mean for countries like India? So what happened in Europe afterwards? We have now for sure an increased awareness of everybody, of tunnel managers, of operators, also of the tunnel users with respect to tunnel safety topics and their complexity. And therefore it's also acknowledged that we need a more systematic approach, and therefore the use of sophisticated tools like quantitative risk assessment for risk-based decision making was introduced. Now when we look at India, we see that you are building up your transportation infrastructure. So that means now you are in a situation where you have to take a lot of decisions which influence tunnel safety for a long time. But there are other aspects which may be more in the focus. You have for sure significant risks due to natural hazards on your open road sections in these mountainous areas, as we've seen, like landslides, like avalanches. And tunnels may be a measure to mitigate these risks, because you can avoid them when you're in a tunnel. On the other hand, you for sure have a lot of traffic safety issues on the open road sections. So it could be interesting to decide, where do you invest your money? Do you want to invest it to increase the tunnel safety a little bit, or do you want to invest it on open road sections, which could be more cost effective? What I wanted to say is that the risk assessment of tunnels and the safety in tunnels has to be assessed from let's say, a higher level. So you also have to implement it in a specific environment and in the specific requirements you are facing in your country. But nevertheless, the European experience could help you to take informed and balanced investment decisions now and to avoid expensive modifications later on. And these new methods and tools that you can also apply in your environment. and you can take these specific boundary conditions in your country, you can take into account by making trade-offs in the decision-making process itself. So it's no problem, you can use these methods and approaches as well. You can even use it for other purposes, because the general method is generally applicable. Now, let's come back to some principles. What is it when we talk, what do we do when we talk about risk assessment? One thing is, we want to take a realistic view, and this is that we have to acknowledge that the risk is never zero. You always have some risk. And then we take a closer look and we address this risk. So we analyze functional interdependencies, we quantify as much as possible, we use historical data, technical parameters of the tunnel system, traffic data, and there are still some gaps, then you fill it in by expert judgment. And then, with this information, you build a realistic model of the tunnel. And what is important to know, if you calculate some risk figures, be aware that these are not real in a sense that we will predict what will happen. This is not the purpose. The purpose is that they should show a representative picture of what can happen, how often, and what can be the consequences. And when we have done this, the question is, why do we need this? So you can apply this for design decisions in the planning phase related to tunnel structure, to equipment of new tunnels. You can, and maybe even more important, you can decide on safety requirements for the upgrading of existing tunnels. And of course, it's important if you want to implement additional risk mitigation measures that you get some idea how effective they are. So you can use this as well for the assessment of the effectiveness of additional risk mitigation measures, for instance, to compensate specific characteristics of a tunnel. Then you can select the best suitable combination of risk mitigation measures by combining the result of the risk assessment with a cost-effective analysis. You can compare with which combination of measures you can get the best effect with a certain amount of investment. And of course, you can also decide on operational strategies for emergency, for instance, how to operate the ventilation in specific situations and things like that. And finally, this is all for the purpose to demonstrate that your tunnel has a sufficient level of safety. And this may be important if you have deviations from prescriptive requirements, or also in exceptional situations where you have reduced safety levels. For instance, the construction phase of the upgrading of existing tunnels. Now, let's have a look at the measures. How do you do this? At the method, how do you do this? So, a preferable tool for risk-based decision-making are for sure quantitative tunnel risk models. And the principle of quantitative tunnel risk models is that if you have an incident, and you see this in this famous bow tie model, you have on the left-hand side, you have the potential causes of this incident. So there may be different ways which may lead to this incident. And if you want to have measures on that side, they act on prevention. So if you can prevent a course, then the incident will not happen. But let's also have a look at the right-hand side, and this is the consequence side. There, if you have an incident, it may develop in different ways, and there you also can implement measures, and this is the mitigation side. So, and a good risk model must be capable of quantifying the effects of risk mitigation measures on tunnel safety. And this is by modeling the influence of a specific measure on the functionality of a specific tunnel safety feature. And at each individual influence point in this chain of events, or these many chain of events you have in there. And of course, you have to cover all the relevant incidents. And therefore, we don't have only one tool for risk assessment. There are several different tools. And the quality of a tool, there is not something like the best tool, fit for all purposes. You have to select it carefully depending on the purpose, depending on the problem you want to investigate, and also depending on maybe the availability and the quality of the input data you may get. Now, how do you evaluate results? There are different methods. I am just showing one of them. What you see here are, this column is more or less representing the risk of a tunnel. It's divided into collision risk, the blue part, and fire risk, which would be the red part. And then, for instance, you could define one reference risk profile. For instance, the tunnel which is completely complying with your guidelines. And if you have a situation that that this risk reference profile is exceeded, you have to implement measures. And by implementing measures, again, you reduce this risk. And you can see here two solutions on the right-hand side where the risk is below this risk reference profile, and that would be an adequate measure. Now, when it comes to tools, I want to present you one example of a risk assessment tool, and this is the Austrian tunnel risk model. It's coming back again what I have been explaining before, this bow tie model. So first you have to look at an incident, an initial event. And this initial event you have to split up into different scenarios to cover the whole range of potential incidents that may happen. So this is called the frequency analysis, and you calculate the frequency of this individual path of incidents. And then you come to the consequence side, because for all these incident scenarios, you have to calculate the consequences. May it be mechanical accidents with causing injuries and fatalities. Here, typically, we use statistics. Or may it be the consequence of fires. Here, typically, we use modeling. And if you combine the frequency of these incidents with the consequence of incidents and you sum it up, then you get the risk of one specific tunnel. So, when this specific model, it works like that. On the one hand, in the frequency analysis, you can cover many different incident scenarios. This is breakdown or malfunctioning of a vehicle causing a fire. This is something which happens quite often. So when we look into the fires, this is the most frequent type of fire. Then, of course, a breakdown or a malfunction of a vehicle can also cause a collision. And the collision, again, can be with or without fire. And then you can have a single vehicle collision. Imagine a vehicle crashing into a tunnel wall. And again, you can have this collision with or without fire. And then you can have different types of collisions involving more than one vehicle. It could be a head-on collision. It could be other types of collisions, and again, with and without fire. And then when it comes to the consequence, I would like to focus on the fire. Because here we have a specific workflow for individual fire scenarios. We have different fire sizes representing different vehicle types. Typically we use 5, 30 and 100 megawatt, but it could also be different. Then we apply a one-dimensional CFD airflow simulation for the global smoke propagation, combined with a three-dimensional airflow simulation for the local smoke propagation. Then we combine this again with an egress simulation. We simulate the behavior of the people in case of a fire. And then with an exposure projection, we can calculate a factual vitality rate for these assessed scenarios by applying an accumulated-based intoxication model. This means that all the effects acting on the people exposed to the effects of the fire are combined, and as soon as they reach a level that the people cannot evacuate, then they are counted as fatality. Now, to get the representative result, you do not have to study only one scenario, you have to study all relevant scenarios to get the representative picture. Now, when you have a closer look into the fire modeling, this picture is representing the one-dimensional airflow situation where you can model the traffic movements, the fire location, the ventilation effects, and also the meteorological boundary conditions. We have heard a lot yesterday about these effects of different pressures on both sides of a tunnel, so we can all implement this into this model. And this model is not a stationary model, it's a transient model. So that the changes over time are also taken into account. And then you superpose this one-dimensional situation on the local situation, a three-dimensional local situation where you do 3D CFD modeling. And by that you get a very flexible model that can easily be adapted to many different boundary conditions. I show an example. This is what we see here is a longitudinal section of the tunnel, and there are different, and there is a timeline with 60 seconds. So you see here a fire starting up and smoke propagation into one direction because there is an initial airflow from the right-hand side to the left-hand side. And then this is just one scenario, one fire scenario over time. And then let's assume we implement some measure. We have here a fire brigade located close to the tunnel portal. So the fire brigade approaches the fire site and starts extinguishing the fire. So after some time, the fire is extinguished, and then the smoke is blown out of the tunnel. So this is represented here. And this is just one scenario. And then if imagine that you do this for all imaginable fire scenario in this tunnel, and then you get one risk figure representing more or less the fire risk of this tunnel. And this is then the number which is represented here. But you have both levels. You have the detailed level you have to take a look into, and you have the global level. Now, I want to stress and address one topic a bit more closely, and this is this topic of the new energy carrier vehicles, and Peter Sturm later on will give a more detailed lecture on this topic. So what's going to happen? You all know that we are now, in the course of the decarbonization of the transport sectors, we get more and more electric cars in our tunnels, and then we have to look at new hazards. The classical risk assessment approach, let's check the new hazards. And in Europe, there have been quite a lot of research projects on that to study the physical consequences. I just mentioned some of them. There are some, quite a lot more. There was this BRAFA project in Austria where we did fire tests with electric vehicles. There were some research projects from the German Highway Research Institute investigating the consequences on risk. And then there are other projects which are looking into the hydrogen topic. Now, when it comes to the battery-driven vehicles, the first question again is, if you do a risk assessment, you ask the question, what can happen? So what can happen? The main concern is the thermal runaway of a battery, which is causing a fire. And the specific thing for battery fires is that they may release extremely toxic gases, in particular hydrogen fluorine. So therefore we have to check what can be the consequence of this. We have also to consider that this is a technology which is developing rather quickly. So we have to maybe have a look on the topic again in a couple of years. So we need a constant observation of this topic. And one specific aspect I want to highlight is that as this technology is quite new, we're still lacking data on the probabilities. So we don't have really fire rates, but we assume that they are probably lower than those for conventional cars. You remember, we always need the probability side and the consequence side for a risk assessment. So, which scenarios are we ending up? We have two scenarios. On the one hand, we have again the technical failure, which may cause a fire in the vehicle body. And then, this is a slow fire growth, and then this may trigger a delayed thermal runaway in the battery. But there could also be a damage directly to the battery as a consequence for collision, for instance, which is causing an immediate thermal runaway. We studied this in the fire tests, and what you can see here on the right-hand side, this is more or less the heat release rate for a conventional vehicle. This is the blue line, and for battery electric-driven vehicles, these are the green and the yellow lines. For the conventional vehicle, you can see that you have an increase of the fire in the initial phase up to more or less 2 megawatt, and then a constant heat release rate and some further increase at the end. This is when the petrol gets involved. And when you look at the battery electric vehicles, the green curve represents a fire where the fire is immediately initiated and started in the battery. So you have an immediate and rapid growth, and then a stabilization. And the other one, the yellow one, is showing the situation where you have a vehicle fire and the battery is ignited later on. You see that here the peak release rates are about 7 megawatts. So, as a conclusion from that, we defined standard fire curves we can apply in the risk assessment you see below. Again, the blue one, I think the colors are wrong. The blue one would be what is the yellow one here, and then the blue dotted one represents the fire starting in the battery, and the other one, the gray one, represents the one with the late ignition of the battery. And we can use these fire curves in the risk assessment. To come to an end, I just want to give you a short overview of what PIAC was doing in the risk sector and the tunnel safety sector in the past years. So we've been publishing a report on risk analysis for road tunnels already in 2008, which then was followed by a report on the topic assessing and improving safety of existing tunnels. So this is more the refurbishment topic. And then another report on risk assessment, in that case focusing on the evaluation of the results of risk assessment in 2012. These reports are still representative. Of course, now we have much more experience in practice in applying these tools, but the principles are still the same. Then we have published another report in 2007. It's focusing on the experience with significant incidents in road tunnels, more or less collecting some incident data, giving some overview with experience of different tools, with this tunnel safety inspections and things like that, also with the application of risk assessment. Then we have had a focus in the last cycle on prevention and mitigation of tunnel-related collisions, because we know that collisions in tunnels are also different from collisions on open roads. And last but not least, right now we are working on the topic road tunnel resilience. So we're not only looking on the safety topics, but also on the availability topics and all those topics related to resilience. Also the question of how long is the duration of the interruption of traffic in case of an incident? What can you do to accelerate again, to put it into practice again? So we will be, at the end of this year, we will publish this report, and all these reports can be downloaded from the PIAC web page for free. Now, let me come to an end of my presentation. A short conclusion. Well, we can for sure say that the European road tunnels, we have now a very high safety level. Due to all these implementation measures following the EC directive. So there was a big refurbishment program implemented between, let's say, 2015 and 2020, and the result is for sure a very high safety level. So that means that further improvements of tunnel safety are often very cost intensive. So you need a balanced approach, because if you focus on a few sometimes very extreme scenarios, you may result in an unbalanced safety level and in disproportionate cost. So, and in many cases, to achieve this, you have different options to reach a safety goal. And therefore, there is an increasing need for informed decisions, and therefore there's a rational basis for this complex type of decisions. You need a systematic approach, and this is this quantitative risk assessment approach. So, if you have an advanced risk model, you have a lot of options to support this informed decision making, and it's very important to imply them as early as possible, because you must have in mind these decisions, if you start at the design of a new tunnel, for instance, you take in a very early design phase, because then you decide how is your tunnel system developed. So you need to apply this in an early phase, and this is also possible. So what we also do, and this is a constant development, the range of application is continuously expanded by feedback from experience. So we learn by applying the methods, we learn by implementing new data and new information. Then, of course, we always implement new features. For instance, we are now able to assess the effects of fixed firefighting systems. We are able to implement the effects of new energy carriers. And of course, there is ongoing research. As I mentioned before, for instance, another topic which is of high interest, this is more related to urban areas, this is how to assess the risk in complex urban tunnels. So, this was my presentation. Thank you very much, and I would like to close with a nice view on Austrian mountains. Thank you.
So Bernard, we can take a few questions. Please. First, do introduce yourself, and then you can pose the question.
Hi, this is Daria from AD Automatos, the managing director of the company. Now, you have shown that regarding the risk analysis and all those things over there, the second point you have said the availability is the major concern for the next part, right? So in this particular terms, this is the software which is going to give you the resultant as complete RAMs, or just the designing portion, or how exactly it is going to be?
I'm not 100% sure if I understood your question correctly. So what we calculate with this risk model is the personal risk of the tunnel user, so the people who are driving through the tunnel. And of course, this is a combination of the frequency of incidents with the consequences. When we look at the availability topic, we can also use these approaches, but then we mainly look at the availability side. And then you have to assess the consequences then in a different way, because the consequences then would be the damage to the tunnel and the interruption of the service, the time of interruption of the service and things like that. And when it comes to the availability of the safety systems, this is something you can take into account in the risk model by assuming that only in a certain percentage of the cases the systems are working as they should. So you can assume a certain percentage where they are not working as they should. Is this the question, or is it something different?
Yeah, that is true. Now you have again said something like safety system.
Yeah.
According to you, what are the safety system? What do you consider that as a safety system?
In
Ventilation part is right.
Yeah, in
Apart from that?
In principle, all the if you remember maybe the chart where I was showing this holistic approach, in principle, all the elements which are influencing safety, for sure it's the ventilation, but it's not only the ventilation. It starts with the detection of the incident, then causing the fire alarm, then starting up the ventilation, including the information to the people so that they can evacuate. So it's not only the systems itself, it's also the combination of the systems with the behavior of the people.
Right, okay.
Thank you very much.
Thank you.
Anyone else? Please introduce yourself first.
Good morning. I am S.S. Gehrwar, Chief Scientist, Central Road Research Institute, New Delhi. Very nice presentation, and my query is I was happy to see your conclusion, and especially the conclusion number 1. Mm-hmm. Then I was also enlightened that you introduced the topic of electric vehicles, and you showed that the scenario may change, giving some gray areas. Mm-hmm. And you also suggested that we have to wait and watch. Now, how do you correlate your first conclusion with this electric vehicle scenario, where you yourself have said that certain period of waiting is required? Thank you.
So I don't say that we need to wait. So I said that we have to watch how this development will go on. But the situation with the new energy carriers is now that we don't know what will be the situation in 5 years. So what we can do, we can assume now, based on the technologies we know, based on the knowledge now, we can do our best possible outlook. Yeah? Because we are aware that we have now have to take decisions for a tunnel which has a life cycle of 100 years, and of the tunnel systems which have a life cycle of 20 years at least. But this is the only way how we can do it. So we can only take the information we have now and try our best to look into the future and see, on the one hand, what will the technology be. This is maybe more difficult, but also the question, what will be the share of new energy carriers in 5 years, in 10 years? Difficult to predict, but what we can do is we can make assumptions and we can do scenario studies. So then we can say, okay, with the development, with the fast development, we may have, let's say, 20% in 10 years or something like that. And then we get the range. At least we can assess how significant is this influence. Maybe it's not significant. Then we can make, it's okay. If it is significant, maybe we have to take a closer look. But what we can do with these tools is exactly this. You can do studies, you can define scenarios, and you can check what is the outcome of these scenarios. And then you get a better idea of what can happen in future. But we cannot predict it.
So, thank you, Mr. Bernard, for that very interesting presentation. And you are very much prepared, like what is required for India, especially while you talked about comprehensive tunnel safety and looking at natural hazards, looking at the traffic safety issues. So that's how to develop a life cycle perspective of tunnel safety. So thank you very much. With that, I now request the co-chair to introduce our second speaker, Ms. Helen, and invite her for the presentation.
Thank you very much. The second presentation will be given by Hélène Mongeau. She's working for CETU. This is a French tunnel safety study center. And she's head of the safety department at CETU. and she's a long experience in working in these topics. Before this, she was responsible for the tunnel operations department, and she will present us today the implementation of safety management systems. This is an innovative approach dedicated to safe road tunnel operation. Please, Helene.
This one? Okay. Good morning, ladies and gentlemen. So I'm going to present this innovative approach which we have experienced in France for the past 7 years. The content of my presentation will first be a short reminder of the French context. Then we'll go through the definition of a safety management system. Then I'll tell you about why we should implement safety management systems for road tunnels. Also, I present the methodological work that we've done at CETU, and I'll give you a short outlook of the implementation of tunnel safety management systems on the French national road network. And finally, conclusions and perspectives. Important works and significant investments have been made for safety improvements in France in French road tunnels since the Great Fires, which occurred in the Alpine tunnels in the years 2000. About 1 billion euros have been invested so far. These investments involved considerable infrastructure replacement and also equipment upgrading and development. Numerous steps forwards have been taken and regulations have been set up to develop technical systems, to offer suited technical measures, and also to elaborate the organizational dimension of safety, which includes safety exercises, operation feedback, maintenance, inspections, with the involvement of all stakeholders. In consequence, tunnel operators' roles are essential for this comprehensive process. In 2015, an audit has been completed in France on the implementation of the safety improvement policy for tunnels on the national road network. It pointed out the importance to maintain the level of safety through time, and also it recommended to develop safety management systems for the 44 tunnels which are involved in this national road framework. Those involve 14 tunnels on the Trans-European road network. And this should be done, they said, in a time frame of 5 years. So this number of tunnels here, the 44 tunnels, represent about 1/4 of the French tunnels that exceed 300 meters in length, which is the regulatory threshold for applying the tunnel safety regulation. These safety management systems are actually a response to the need for a tunnel operation professionalization, and they can be seen as one of the main results or main, I should say, lessons learned after about 15 years of implementation of safety procedures in the French road tunnel context. First of all, what is a safety management system? As Bernard recalled earlier on, for tunnels, when we speak of safety, we rely on a holistic or systemic approach. This involves, as you know, the 4 parameters, which are the users, the vehicles, the infrastructure, as well as the organization. These parameters are interdependent, and they are all involved, they all condition the safety level in the tunnel. Also, the tunnel safety regulation, with its tunnel documentation, which is represented on the right side of the slide here, relies on the principle of continuous improvement through time, with a first circle, which is the everyday virtual circle, daily improvement cycle involving the annual exercise, feedback from experience, and also the analysis of incidents and accidents. And you also have the periodic 6-year virtual circle with a safety level exam. I just told you about continuous improvement in the tunnel safety documentation, but we also considered quality approaches. These approaches enable to better structure the organizations and also to meet the customer's needs. The aim is to constantly improve the organizations under the principle of the Deming wheel, which you see here on the screen, through 4 steps that you repeat: plan, do, check, act, in order to satisfy the customer's requirements. Note that in France, state road operators have developed such quality approaches about 10 years ago. So when you combine the two, you get what we call a tunnel safety management system. You have the systemic approach and tunnel safety regulation, which you combine with a quality management system approach, and you get a genuine safety management system dedicated to road tunnels. In short, it could be called quality management systems targeted towards tunnel safety. It does not mean that a tunnel was not safely operated before, but now you're going to structure and pull together in an organized way existing good practices. You're going also to put them in perspective in order to identify weaknesses and to improve them, and then you go on continuously. A possible definition of a safety management system is the one which is shown on at the bottom of this slide. In this definition, SMS is a collection of structured company-wide processes that provide effective risk-based decision-making for daily business functions. Safety management systems help organizations offer products or services at the highest level of safety and maintain safe operations. So why should we implement safety management systems for road tunnels? The first reason is to professionalize the management of risks that are linked to the operation of road tunnels. Our objective is to improve the safety management. We will have to consider risks then, risks that are associated with a safe operation of tunnels. And we know that those risks rely on the 4 parameters which I mentioned before. So the SMS will rely on a systemic approach. The second reason is to ensure the good functioning of the safety system through time. The good functioning through time can be guaranteed only if it's regularly monitored and regularly assessed and in a systematic manner for all its components. So the SMS will rely on a systematic approach. And the third reason is to ensure a traceability, so that actions that have been taken and decisions which have been made can be retrieved. And this ensures a legal security. Once we were convinced that SMS for road tunnels are of interest, the next question was, how can we do that? Rather than inventing a new method from scratch, we had a look at other transport or industry domains, and we noted that French and foreign regulations enforce such SMS. Sometimes they have even done so for more than 20 years. So here on the slide, you can see that in the industry, for instance, there are classified facilities since year 2000 in France. In the air transport domain, since the beginning of the years 2000, there are international regulations for SMS as well for air operators, transport companies, as well as maintenance organization. In their railway transport and ropeways in mountainous regions as well, you have such SMS, which are mandatory in the regulations. So in 2017, we launched a benchmark, and this benchmark dealt with 6 existing SMS in the transport systems: air transport, rail transport, urban guided transport, as well as ropeways in mountainous regions, and in the industry with nuclear facilities, classified facilities for environmental protection that are subject to specific regulation. An analysis of the SMS regulations of these sectors have been made, and interviews have been carried out with operators and control authorities, or let's call them inspection bodies, for each of these fields, involving a standard questionnaire and also an analysis matrix which had been drawn up in advance. And a SWOT analysis was also carried out, in addition to examining tools and procedures. The benchmark study has put forward the following 4 pillars for an SMS. First of all, we must have a clear safety policy in order to define the directions and the actions to be made in a consistent manner. The second pillar is a structure, that is to say, an organization with a clear definition of who does what, with clear roles and responsibilities, accountability, also procedures to know how to perform the tasks, indicators to measure whether the objectives are met, control and monitoring tools. The third pillar is an assessment framework involving feedback, analysis, audits. And the fourth pillar is the development of a safety culture in everyday work life. A culture which is actually shared by all staff and partners. The main lessons learned from the benchmark are as follows. The first key to success is simplicity, in order to facilitate the life of the SMS and the updating of the procedures. Also, the evolution of the maturity level is in the nature of the SMS itself, because of the continuous improvement principle. So when we start building the SMS, we first get an experimental SMS, and we shouldn't want it to be comprehensive from the beginning. We must acknowledge that it will be complemented progressively. The third question was, should we have sample manual for SMS from the beginning? We answered this question by saying that it was a possible work basis, but it's essential if we start from a sample manual that it's adapted to the context of each tunnel operator. Fourth issue is that the SMS must be useful to the operator. It should not take over from the operating task. We want the energy to be invested in the content and not in the container. We should also give importance to the commitment of the accountable manager. He's the one who defines the safety policy. Also, consideration should be given to the organization to be set, as I said earlier, who does what, with a clear definition of responsibilities, in accordance with the size and the stakes of the structure. We should take into account the number of tunnels operated, how much traffic, the number of events in tunnels, so that not too much importance is given in an operating body which operates only one or two tunnels. Also, the SMS pilot is the important person who coordinates and implements the SMS on an everyday basis. We should also take into account the articulation with quality procedures, and in case we are on a 10T road network tunnel, there should be a tunnel safety officer, and we should look after the articulation with a tunnel safety officer whose duties encompass most aspects of the SMS. Now, when we transpose the SMS components studied in the benchmark into tunnels, we get such a list of tunnel SMS ingredients. I'm not going to read it all, but you may see that, for instance, we have the safety policy. We also have training and skills management. We have asset management, including maintenance for both equipment and civil engineering. We have feedback management. So what remains to be done for implementing SMS for tunnels covered by the French regulation? Once again, the safety documentation regulation provides the basis of an SMS for tunnel operation. So the keywords, which are written in green here, remind that we have to start from existing practice, and we shouldn't build a labyrinthine system. Also, we should complement only the very necessary parts. And we should set up an approach which is adjusted to the organization and local issues. Thank you. Okay. So the first step will be to identify risks, to prioritize them, connect them with safety objectives. Then we should specify who does what. Next, we should formalize the internal process and implement tools, and then set up a monitoring and assessment framework so that we get a simple and effective daily tool to safely operate road tunnels. Just a quick word about the SMS approach we had on the French National Road Network. This approach was built as a co-construction initiative by operators and the CETU, with a very strong involvement of tunnel operators. We set up a working group, which was chaired by CETU, and the group, which started working in 2017, initially defined its SMS as the definition you can see in the frame here, which is the organization and provisions which have been set in order to optimize the safe operation of road tunnels by managing risk efficiently and in accordance with the stakes of the operating body, operating activity. Just to give you an idea of the main milestones, as I said, we started the working group with SMS pilots in the 8 state tunnel operating bodies in July 2017. 1.5 years later, they had experimental SMS being operated in their operating bodies. And we can assume that at the beginning of 2021, these SMS had been complemented, and we started calling them consolidated SMS, although they still continue improving themselves through time. This is an overview of the same time scale, 1.5 years for building SMS. And in these slides, you may have an idea of the evolution of the opinion of tunnel operators while they were building their SMS. The great fear at the beginning was to have unnecessary complication of the organization and an additional layer of complexity with unnecessary paperwork. Then when they finished the big building phase of SMS, we could, they acknowledged that, for instance, there were more numerous exchanges between actors, and also some efforts had been made to formalize the procedures. And when we get to the operational phase of SMS, then we can hear them saying that the SMS clearly improves the level of safety perceived by all staff, and that it helps identify weaknesses in the organization. We also have a few results from the audits that have been done by CETU. I'm not going to read them all because we ran out of time. Just mentioned, for instance, that the information is better shared within the organization after the SMS has been built. And as a conclusion, I can say that this approach has been a voluntary approach. It was not imposed by the regulation, not mandatory. Also, it's been a real innovative approach because we have run it for the first time on the tunnel safety domain. Also, the tunnel SMS could be considered operational after about 2 year or 1.5 year building stage, and after 5 years, they've been considered sufficiently mature. It's been a positive approach for tunnel operating bodies and for the safe operation of tunnels, but again, it does not mean that tunnels were not operated safely before. And in terms of perspectives, we have now new tunnel operators that want to develop such an approach. So we will have at CETU, we will have to support them. And we are currently preparing, writing a methodological guide, which should be ready by the end of this year or beginning of 2024. Thank you for your attention.
Thank you. Now we can take one or two questions.
Can I sit down? Thank you. Stan Lopaczynski, Austrian Tunnel Authority. We have something similar, so I'm very curious to know. The last slide, you said there were these measures were not imposed; they were just made voluntary. Also, what does it exactly mean? How was this cooperation between the authorities, CETU, and tunnel operators? Were they involved in creating those SMS at the very beginning, or they were just told at the very end, okay, this is what we are going to do. If you are okay, please do it. What was the way? How did you get to this point where you are today? Thank you.
If you remember, at the beginning of my presentation, I mentioned that an audit had been required on the safety level, let's say, of tunnels on the road national network. And one of the results of this audit was that, well, it was a recommendation. It was not something we had to do by regulation, but it was a recommendation that state-owned road operators should develop such SMS with the assistance of the CETU, who is a Center for Studies belonging to the Ministry of Transport. So we are all in the same ministry, and the CETU provided this methodological assistance to the road operators. Well, we organized the first meeting in 2016 to present what this kind of method could represent in terms of objectives to reach, in terms of interests that we could expect. And there was actually a direction also that was given by our head of ministry, asking these tunnel operators to start to launch the approach with the CETU. And we actually worked in a very practical way. We set up a group of representatives from these 8 state road operators, and we had 8 representatives who became the 8 SMS pilots within their structures. And little by little, because we got the results from the benchmark that we did, we provided the CETU provided methodologies to build this SMS, which were inspired from the other domains. And the group could meet about every 2 months, and we could share experience, or the pilots could share experience from the building of these SMS in their structures.
I think I have to rephrase my question.
Maybe I request we continue beyond after the session, during tea time.
Thanks very much.
Because we have a third speaker. So just one question from the middle. Please be brief.
Yeah, good morning. My name is Sunit Dhar. I'm at TVS and TFSS engineer. My question is to Helen. It is regarding the CETU publications, because I know CETU is one of the, particularly for the risk management and the other safety. So is it available online, or how can we get all those documentation online, or can we purchase those online?
The documentation is being written, so it's not available yet.
No, no, not this. The previous, all the SETU publications.
Oh, all the SETU publication is available on the SETU website.
Is it free download or
It can be downloaded for free.
Okay.
And most of the time you have an English version of the documentation.
Right. Okay, thank you
Yes.
very much.
Okay, thank you very much. Thank you.
Okay?
Thank you. With that, we now move to the third presentation by Mr. Peter Sturm. So the co-chair will introduce.
Yeah. Next presenter, Peter Sturm. He's professor at Graz University of Technology in Austria. He holds a PhD in mechanical engineering, and his current position in the Graz University is head of the section Traffic and Environment. He's deputy head of the Institute of Thermodynamic and Sustainable Propulsion Systems and dean of studies at the Faculty of Mechanical Engineering. Peter is also member of PIAC's Technical Committee on Tunnels, and he's currently leading the working group 4 dealing with new energy carriers. And this talk today is about this topic, so we are looking forward to your presentation, Peter.
Ingo, thank you very much for this introduction. Ladies and gentlemen, I'm pleased to have a talk about this topic, which is not new anymore, but it is something which is already coming now to the, it's in the market, but it's coming now in our tunnels, and we have to deal with it. As I was introduced already, so it's no problem to speak anything about me, but I would also like to acknowledge the work of my co-workers, Michael Barker and Patrick Fössleitner, on this work, or on the presentation. The work has been done within the working group 4 of PIAC, and I bring you some of these results. So we know exactly that these vehicles are becoming more and more prevalent. In some cities, especially in cities, they have already some 10-15% of the passenger car share. And this might have an impact on the nature, on tunnel safety risk, mainly including from fire. And when we speak about new energy carriers, we have to consider that we are speaking about battery electrical cars, hydrogen-powered fuel cell vehicles, hydrogen or synthetic fuels in internal combustion engines, or, which is not really a new fuel because it has been here now for a long time, internal combustion engines using compressed or liquefied gas like CNG, LNG, or LPG. Especially CNG and LPG cars are here. We know that they are on the market. We didn't have major problems up to now with them. LNG may be a little bit more problematic, but they are bridging technology, so I wouldn't call them really as a new energy carrier. There was already a question, I think it was to Bernard Kohl, and it's what is going on in the future. We don't know what is going on in the future because this is strongly policy driven. There is an expected fleet penetration of NAC vehicles as an example from Germany, for example. If you go on the car side, then up to 2040, conventional cars will have a medium share of the fleet. Battery electrical cars might have a high share of the fleet. Fuel cell electrical vehicles, I would say maybe a medium or even a low one on the passenger car side. If you go to the other side, you have the heavy duties and especially the buses. Then you would have, most probably in 2040, this was the expected result, you have a high share of conventional cars, buses, conventional ones, internal combustion ones, hybrid ones, battery electrical vehicles, but CNG, LNG might be here also on the road, especially LNG on the coach side, and so on. So it's just a guess. So we have to deal with the whole thing. This is the only information which I want to say. This picture you saw already, and you already heard from Bernhard, where we have these problems. We have the fire. The whole floor plate of a vehicle is the battery. So it's a big part where you can have an impact. And we have two sources. One is a fire directly starting because of a technical defect in the vehicle or in the battery. Or we can have a collision, and then the fire can spread from one vehicle to another one, or the fire starts from the battery because the battery was damaged in this collision. So this is just a picture of one of the tests which we made, and what you can see here, this is a typical battery electrical vehicle. Fire, because you have a very high dynamic on the low level here, on the very high dynamic of the fire, because the battery is burning. Here in this case, battery was damaged, so it was quite easy to trigger a fire. It's an older car. It's a car from 2015. I say this is an older car because the situation has changed. I would like, there was already a research project mentioned, it's BRAVA, it was a research project going on in Austria. A lot of institutions participated, including ILF with Bernhard Kohl. And the only thing I want to show you here, if it works, is a video of one of these tests, which is from a new vehicle. And what I have to tell you here, you see the vehicle is burning. It's a vehicle with an 80 kilowatt hour battery pack, and the vehicle is burning, and the vehicle has been burning. The fire started in the compartment. The fire did not, so we ignited the compartment. So simulating something which happens in the compartment. So the battery was not involved. It took 10 minutes, and the full car was already burned. So there was a big conflict of interests. We wanted to see the full fire. The fire brigades always wanted to extinguish the fire. So we had to keep them a little bit away to see what is going on. And after these 10 minutes, there was still no activation of the battery. So we did something externally. From externally, we ignited the battery. Oh, sorry, this is not what I wanted to show. Let's try it once again. And I go immediately to this part. So it's still not burning. And now you see something, we just put some acid into the battery. And now you see the dynamics here. Now the battery fully is involved in the fire, and this resulted in a strong increase in the heat release rate. This was maybe one of the peaks which you saw in the slides of Bernhard, up to 7-8 megawatt, which is almost unusual. But you found this, but this is because the full dynamics of such a fire. So all the videos are available on YouTube, so it's no problem to have a look at that later on. But what is the most important things? This is a collection of data from tests made on battery packs in former years and on full vehicles, mainly in a project made by Ineris, but also in the 2010, 2015, but Swedish project, the ETOX project, very recent project, 2018, 2020, our BRAVA project. So having small energy content in the battery up to very high energy content in the battery. So the watt hours, it's a double logarithmic scale, so take care. But you see there's something in the double logarithmic scale, there's a linear relationship, very simple. The higher the energy you store in the battery at 100% status of charge, the higher is the heat release rate. So what we found out is that the maximum heat release rate may be a little bit higher than that one of a conventional car. So not very much higher, but it's maybe a little bit higher than a conventional car. The average heat release rate is more or less the same, but we're speaking about cars and not about big vehicles. What is different are the toxic gases. In general, the standard gases like CO and other carbon-related products are not differ. They don't differ a lot. The only thing which differ is hydrogen fluoride, and hydrogen fluoride is not a very. It's a harmful gas, so you have to take care about the whole thing. There is no clear relationship between the electrical energy stored in the battery and the amount of hydrogen fluoride produced, but there is one thing. The yellow parts here in this picture were made from the test from Ineris and CETU in around 2010, while all the others are from 2020. So you can see there is more or less a decrease between the high values which were found in the older vehicles to much lower ones which are found now. And for the 80 kilowatt hour battery, we have found something in between. So there's a change in technology. And this is something which makes it very important to look at the technology, and it makes it very critical if you make a risk assessment for the future because you don't know how the technology is changing. The chemistry is changing. Everything is related on lithium-ion batteries, I have to say. So we were looking at different situations, how you can extinguish such a fire. You know, in many countries already there are such type of blankets used to extinguish the fire of a conventional car, because you just put the oxygen out of the whole thing. Of course, this is not possible as soon as the battery is involved in the incident, because you have the oxygen in your battery. So the oxygen is here, so you can cover the whole vehicle. There's so much oxygen stored in the electrolyte in the battery that it will not help you. It's still a lot of water which is needed to cool it down. It has to come to the battery. The only thing which proved to be very effective, I would have a slide, but I think we're running out of time in this case. It shows you if you directly bring the fire into the casing of the battery. You know, the battery is sealed in a big metal casing. If you bring the water directly in this in this casing, then a relatively small amount of water is sufficient to bring the temperature down below the thermal runaway temperatures and definitely to extinguish the fire. This is now there are already some tools from companies on the market which provide you such equipment, with such an equipment. When we go to hydrogen-powered fuel cell electric vehicles, this is also something which is new, a hydrogen vehicle, but it's coming now on the whole thing. Then we have a totally different risk. And everything which I say here for hydrogen-powered fuel vehicles is more or less also valid for other gas vehicles. But with hydrogens, we have a very high pressure. In the gas phase, for passenger cars, the tank is stored at, the gas is stored at 700 bar in the gas phase. In the HGV and buses, it's down to 350, but it's still a high pressure. We have also some battery in the whole thing. The fuel stack is here. The battery is somewhere in the rear in this case. But this is much smaller compared to what you have in a battery electrical vehicles. The risks for the tank, for tank rupture and this stuff, it's like for other gases, but as I have told you, we have had higher pressures. And if I put everything together, for example, and show you and speak a little bit about the risks which we're having with such vehicles, then we know CNG, LPG vehicles, they are here for a long time, and we have safety measures in the cars and safety measures to prevent from tank rupture and all this stuff. So there was not a lot of big incidents, and LPG cars are widely distributed all over the world. LNG might be like e-fuels. They might be of interest for long-distance transport, and they have a different risk, of course. When we go to the risks, then we see the gases stored in tanks at pressures up to 700. As I had it before, 700 bars is hydrogen, 200 bars CNG. If something happens, you have a risk measure, or a safety measure, which is a TPRD. I will show it later. Then the whole thing is released and it results in a jet flame. If you have there could also be, if it doesn't ignite, there could be a vapor cloud explosion in the tunnel, somewhere in the tunnel. If you have a tank rupture, then it's much more critical, because in this case the safety measures of your tank did not work, and then you might have a problem. Definitely tank rupture is a problem. If you have liquids, then we have the problem that you store them under a very low temperature. For LNG, it's 130 centigrade minus. For hydrogen liquid storage in vehicles, we can exclude it at the moment, definitely, because no one is cooling them down to 250 centigrade. Costs too much energy to keep it there. So this is not a problem. The pressure would be relatively moderate. But the problem is, if you have an engulfing fire, then you might have I didn't start that, Ola. Sorry. So the problem is that you might have a BLEVE. Okay, what is the problem now if you have a CNG vehicle? Normally in a CNG vehicle or in a gas vehicle you have TPRDs, and the TPRD opens at 110 centigrade, and then you have jet fires like this. In this incident, this was an incident which happened in Perugia, in Italy. If this happens in the tunnel, it's a little bit more problem. So the pressure is roughly at, for TPRD, for the gas vehicles, we have this TPRD. For the liquid storage, we have a pressure-triggered valve at roughly 16 to 24 bars. So tests were made because now we found definitely the tank is the most critical part if something happens. Tests were made by RISE, by our Swedish colleagues, and they made a lot of tests or 8 tests with vessels, and they found that in most cases you had jet flames, and there was no big problem. But in one case, so jet flames up to 10 meters, as you can see here, of course in a tunnel they are a little bit of higher risk, definitely of higher risk compared to the outside. So in one of the 8 tests, a pressure vessel exploded, and you had a very small region of lethal effects, but this was in the open space. And I only want to show you this test where the vessel exploded. But first, one thing, please have a look at the clock here. It's already 20 minutes after this engulfing fire was acting on the vessel. The fire was too small to activate the TPRD, but it's strong enough. This happens. And this, of course, has to be avoided in a road tunnel. So, sorry, I go to the next one. So, let's sum it up for CNG in tunnels. There were tests made from CETU, and it shows that you have to look at a special orientation at the TPRD. The same is for the pressure, so let's say the safety device. If it goes vertically up, it's fine. Then it's no problem also in tunnels. For vapor cloud explosions, there can be the fatal health effect area is in a region in a tunnel, in a standard tunnel with 2 lanes, roughly 25 meters around the whole vehicle. So 12 meters there, 12 meters there. So it's then it's a problem. For tank rupture itself, as I showed it, associated health effects were up to 25 meters on either side of the tank. LNG is more critical because it's not a question of a jet flame or a vapor cloud explosion. It's the question of a BLEVE. So if a BLEVE would happen, that means you have this real big explosion. Then the distance where you have a problem is quite big. But as we know, it takes a lot of time until a BLEVE will be triggered. So there is sufficient time to escape. This results now later, which we have in prior on requirements. You need to identify the vehicles which are in your tunnel. And for fuel cell vehicles, this is a result which came out of a big project in Europe, the High Tunnel project, led by colleagues of Northern Ireland. You see here the ranges of where you have problems in a tunnel. In the standard tunnel, it was more a smaller tunnel than a standard tunnel, but a no-harm zone did not exist in an up to 5 kilometer long tunnel in this case. So to conclude, we have the NAC vehicles which are steadily penetrating the vehicle fleet. For passenger car vehicles, we know a lot of we have a lot of information, and we found there is no big change in the heat release rate. In any way, a passenger car fire is never a dimensioning part for a tunnel ventilation or a tunnel safety system. So it's no risk if we have a higher share of passenger cars. The only problem might be the hydrogen fluoride. But if you have ventilation rates like we have it normal in a tunnel with 1.5 to critical meters per second up to critical velocity, then there's no risk for the people because we have the higher concentrations at the ceiling. And if the smoke is coming down and it's very good diluted, bigger risks we might have with much bigger vehicles. So we have no solid results for buses or heavy-duty vehicles. And for gas vehicles, as I told you before, CNG buses might be a problem, but mainly depending on the geometry of the TPRD range. The direction, and it was found out that the range of such a jet flame which is critical is in the size of the vehicle. So if you have a passenger car, you can have it one passenger car be in the length of one passenger car around the vehicle is critical. If you have a bus, then it's the size of a bus which is critical around this location. And tank rupture is really a problem. Technical measures are avoided to reduce the probability of tank ruptures. And for CNG, we didn't have any tank ruptures up to now in tunnels. And CNG vehicles are here. So it's a little bit more than the 2 minutes. Sorry for this. But I'm done with this one. This is just an image from one of the tests. So if you have questions, I would be very happy to answer them. Thank you very much.
I'm sorry, Professor Peter, for sharing that slip. We have already short the time, but we can take 1 or 2 questions. Yeah.
Yeah, my name is Sunit Thar. I have a query regarding the ventilation for it. Like in PIAC, it has been, there is a guideline in the PIAC 05.116B for the smoke generation for particular for 30 megawatt it is around 80 meter cube per second, and for 100 megawatt fire it is mentioned as 120 megawatt meter cube per second. My question is for the electric battery. What would be the smoke? Is this for the new design of a tunnel to mitigate the ventilation system? So what would be for the electric driven vehicle? Is there any smoke generation been estimated?
Up to now, everything which we know for the electrical vehicles on the passenger car side, as long as you have roughly 1.5 meters as an, let's say it different, you have a cross section of roughly 55 square meters in a standard tunnel and 1.5 meters, so you have end up with 65 cubic meters per second. This is sufficient to dilute the critical substances. If it goes to buses, then it might be a little bit higher, but we know too little about such things because we don't know how the burning behavior of much bigger batteries is. If the burning behavior is only that it burns much longer, then it's also no problem with the ventilation rates which we are having currently. So I would say if the ventilation rate is going down below 50 or 60 cubic meters per second, then you might have a problem. But as long as it's higher, then it's not a problem. The same was found for the gas vapor cloud explosions. So you have a certain dilution, and especially if you would have hydrogen, then the risk of a vapor cloud explosion is considered to be small because hydrogen has a very low energy needed to be ignited. So very likely already the release of hydrogen under high pressure results in the fire. Then you have a jet fire and you avoid vapor cloud explosions. So coming back to your question, current ventilation rates for current knowledge which we are having on passenger cars, battery electric passenger cars is no problem. It will be a problem in confined spaces like in a parking garage without reliable ventilation. Confined spaces are really a problem on the battery side because you don't have the ventilation rates. So it's not the temperature issue, it's more the gas issue which is critical.
Thank you.
Hi, I am Lere Gupta, Technical Consultant, Ministry of Road Transport and Highways. So you talked about new energy carriers such as hydrogen or lithium powered vehicles. So how does this impact the design of a particular tunnel as of now? As of the present vehicles that are already running through the tunnels and the advancement in the new energy carriers, does it have a drastic impact in the, particularly in the design phase of the tunnel?
Again, coming back to the situation, everything we know at the moment where we have reliable tests is on the passenger car side. And the passenger car side has never been a passenger car fire or something like this has never been a design criteria. So if you have a passenger fire, regardless if it's a gasoline, a diesel, or or a battery electric vehicle, the heat release rate is too small to be a problem for a design of a ventilation rate, because you design it, or you design the tunnel for 50 megawatts or for 100 megawatts and all this stuff. So this does not impact, has a big impact. A big impact will come maybe on the, there are available some calculations. If you have the batteries on the top of the roof of a bus in the city, it's electrical bus, and if this burns, then you have the same problems like with a 100 megawatt fire. The results of the temperatures are as high, so you might have structural damages. That's clear. The temperatures are very, very high because the distance to the ceiling is not given anymore. So there it could be a problem, but not on the passenger car side. Why it's not a big problem? First of all, on the structure it's not a big problem, and Bernard Cole and his team made some risk assessments, taking all passenger cars, converting them into battery electric vehicles and looking at the overall risk. There was no big change in the overall risk of the tunnel. Why? Because this was on Austrian tunnels. In Austrian tunnels, I think the majority of incidents is incidents without fire. So if you have only a few percent with incidents with fire, then each change results in a small change in the overall risk of the tunnel. It's more the consequence which might result in a problem with your structure. Big ones.
Thank you. There is one last question.
Hello. Sir, myself RB Shivali, team leader cum senior tunnel expert of Dwarka Expressway. Sir, generally in the Indian tunnel tendency is 50 megawatt we take the fire load. But in what circumstances we provide the 150, 200 megawatt, and what the fire protection system to be applied in this one, sir?
Whether you need a fire protection system or not, it's a question of the structure. With a fire protection system, we know that you can reduce the heat release rate. You can't extinguish the fire, that's at least a big one, but you can reduce strongly the heat release rate, and so this saves, of course, lives. There is no big change. There is already in the Souverän project in Germany, they have the interaction there is an interaction between firefighting systems and battery electric vehicles. So there's no big change. Of course, it's always a question of how much money you are willing to invest the whole thing. With such a system, you increase the availability of the system, because if you have such a big fire, the structural damage is much smaller. So for life risk, I don't think there's a big difference. It's more in the asset protection side.
Thank you very much.
Okay, thank you, sir.
Thank you very much, Professor Peter. I think we had a brilliant technical session. I must compliment all the three speakers and the co-chair for their inputs. We could receive a lot of inputs of the studies undertaken by SETU and the studies of PR. Professor Peter really talked about like what happens in the presence of new energy carriers, and he has provided like what could be the possible solutions. So that's a great insight. And during the second presentation, Ms. Helen Mozo made that statement very effective. Like simple and effective daily tools are essential for safety management system for the tunnels. And she made a presentation through voluntary basis how these safety management systems can be initiated. You can take the tunnel operators into confidence. And fast presentation by Professor Bernard Cole. So here, in fact, he has definitely tried to understand that how the ideas of risk-based decision-making system can be transferred to Indian conditions. And I would like to quote him, like method is generically applicable. So there is like great possibility of using it. And these kind of simulation softwares or tools, they can be very used to understand the effectiveness of various measures. Like the studies they have done, what happens if you have fixed firefighting system, what happens if you put a fire vehicle close to the tunnel. So all those kind of interventions can be analyzed if you are developing this kind of risk-based software system. And I'm sure there is we can learn a great from SETU, from PR, the various documents which are developed, they can be very useful for strengthening the IRC document on tunnel safety. So thank you very much. With that, I'll invite the co-chair for his closing remarks.
I also would like to thank all the three speakers for their excellent presentations and the great preparation of their speeches. Also for sticking to the time schedule. It was very good on time. We started later. This is why we are ending a bit later. I would briefly highlight what are the main takeaways, especially for India. I think this was the most important thing for me in this session to see, especially in Bernard's talk. He told us that this approach could be very much applied for India, that this integrated risk approach could be a mitigation measure also regarding natural hazards, which you have a lot here in India. And you can use this approach, especially in the design phase. I think it's very important to start early, to use these risk-based approaches to avoid later high costs for refurbishment of existing structures. So coming to Hélène Mongeau and her talk about safety management system, for me it is also something which should be implemented early in the design phase, or if you have a tunnel, enter it as early as possible. This safety management system can help to include all relevant aspects of road tunnel safety at an early stage, and also to review it regularly if the tunnel is already operated. So I think it's a very good approach to use this, and I would think this is something which could be also implemented in India for new tunnels. You are building a lot of new tunnels at the moment. Yeah, and Peter's presentation shows clearly that for battery electric cars and for hydrogen-powered cars, this may be a concern in road tunnels, but the knowledge up to now is only about cars, so no heavy goods vehicles covered so far. Toxic gases, only small problems, and extinguishing for fire department is a little bit complicated, so should be taken into account, these new energy carriers. I don't know how high the portion in India is of these vehicles. In Europe it's growing very fast, but still, looking at the overall vehicle fleet, it's still a small portion. There are some countries like Norway where it's completely different, but many other European countries, this is slowly increasing, this share of these vehicles. So we have to monitor this, we have to do more research on that, and India could provide also, use also these inputs which are already available to be prepared for the future. Thank you very much. This was all from my side.
Thank you. Now the session is over to Amit, who was the compere. Thank you.
Since we are done with the discussions, questionnaire and conclusion of our session 5B, we declare this session 5B successfully concluded, for which I thank our chair and co-chair for maintaining the flow of this session well, and to thank which I request Shri V.S. Khara, Chief Engineer MORTH, to come forth and greet and present the mementos to our chair, Dr. M. Parida, Vice President, and our co-chair, Mr. Ingo Kondinya. I would also request Mr. Khara sir to provide the felicitation and mementos to our presenters. First off, presenter Ms. Hélène Mongeau, followed by Mr. Presenter Bernard Cole. And our presenter Mr. Strom. I thank all our dignitaries to be present here. I now declare this session for a hiatus and request everyone to enjoy their high tea with us right outside the hall. We shall convene and continue with our scope of the seminar exactly in 10 minutes at 12 noon. But before we break, it is my responsibility to remind every dignitary present here about the technical site visit in Rishikesh, Karnaprayag New Rail Line Tunnel project. Those who wish to visit this site visit tomorrow at 9 a.m. must get themselves registered at the Vedanta reception at 12:30 or before. I repeat, those who wish to visit the technical site visit of Rishikesh Karnaprayag new rail line tunnel project must get themselves registered before 12:30 today. Thank you, and we hope to convene with you soon. You need to update your presentation.
Well, I didn't actually provide anything else except the PDF.
6 page, so what
Yeah,
was your name?
but Max. Yeah.
Okay.
So he would be
forward, we shall converge our attention to the focal point of our next session of the seminar, which shall be about the insights and information regarding case studies on road tunnel projects, Part 1. This session will be led by our chair, Mr. Tiago Messaging, PIARC Technical Committee 4.4 Secretary, and our co-chair, Shri V.S. Khera, Chief Engineer, MORTS. I request our chair and co-chair to head towards our high table and join us. I would like to take this moment to introduce everyone towards the direction of our session 6B, which shall be presentation on Kashedi Tunnel, a greenfield tunnel with viaducts by Mr. Praveen Sudhakar Dongre, ILF India. Next will be the presentation on best practices to install fixed firefighting systems for road tunnels, case study by Max Lackinen, IFAB, GmbH, ITA Kosovo, Germany. And the last presentation for the session 6B shall be on Sao Paulo firefighting strategies by Mr. Ricardo Miranda, PIARC Technical Committee 4.4 member, Brazil. I now request our honorable presenters to come up on stage and join the high table. Before we move forth with our seminar in session 6B, I request to congratulate our all co-chair and chair, and I request for that Bharat Singh Johaiya, Executive Engineer MORT, to come forth and felicitate our committee. With felicitations done and delight at heart, I now hand over the procession of our seminar 6B to our respected committee.
Good morning, ladies and gentlemen. It's always a privilege and honor for me, particularly to be afforded the opportunity to chair this technical committee or this technical session. Case studies is about a reality which brings us close to what is happening out there. We listen to theoretical concepts, we design projects, but case study actually goes closer and closer. And we are privileged today to have these gifted professionals who are going to lead us with their experience, sharing what they bring to this conference. So we are privileged to have them around the table right now. I want to thank you participants for allocating your time to make yourself available, to learn from them what they are doing in their professional life. And I would like to, at the same time, sensitize our presenters to try to stick to the time, please. If we do that, then we afford the opportunity to participants to interact with yourself, to ask you questions, and to learn a little bit more. I'm going to hand over to my colleague and co-chair to greet you and invite the presenters right away. Thank you.
Thank you, Mr. Tiago. Thank you for the handing over. I would now briefly describe about the credentials of the presenters. Mr. Praveen Dongre, he's a road safety, he's the tunnel safety expert. He's a consultant in ILF, senior manager. His total experience is 34 years, in which 15 years he has worked abroad, 16 years underground uh, 15 years elevated structures. Yeah. So he is the first presenter. He will be presenting the Kashedi Tunnel, Greenfield Tunnel with viaducts. The next presenter is Mr. Lax. He is automation oblique fluid power expert. He is Master of Science, Managing Director of IFAB, Institute for Applied Fire Safety Research, GmbH. He has got research experience. He has got almost 20 years experience in fire engineering industry. Previously, he has been working for over 10 years at the Technical University, Tampere, Finland, and he holds a post-grad degree in fluid power engineering. Max Lekonen is an internationally recognized lecturer and is often invited to speak at various fire protection events. Max Lekonen is also serves in various standard committees and boards. He is the steering board member of ITA SEOF and a principal member of NFPA 130, NFPA 502 and NFPA 750 technical committees. Max Lekonen works internationally as a fire safety expert and typically focuses on projects which require performance-based design, are more challenging or are related to firefighting systems. He has worked specifically for tunneling and transportation industry for 10 years. The common elements for his work are new energy carriers, alternative fuels, transportation, hazards, fire, many good experience and typical to the subject. We will be enriched by his presentations. Our last presenter is Sao Paulo Firefighting Strategies, Mr. Ricardo Miranda. Mr. Ricardo Miranda, certified electronic and mechanical technician, electronic engineer, fire protection engineer, and emergency management specialist. He has got master's degree in operational safety ongoing, managing director of Mirabit Consultoria and joint venture engineering in the Brazil, member of PARC TC 4.4 road tunnels. So he has got very vast exposure and he is a pioneer in Brazilian system, and we will be enriched by his experience of underground ventilation and air quality standards, and it will be immensely useful for our this present session, and it will be cross-seminated across the globe. So I hand over the dais to the presenter. First, Mr. Praveen Dongre.
स्लाइड वाला यही में कौन सा वाला हाँ यही है करेक्ट हाँ यही
Mr. Praveen Dongre, please be brief, and the questions will be taken at the end of the session after three presenters have presented their presentations. There will be a question, and request is for being brief.
Actually, when I came uh, yesterday at Dehradun airport, so I remembered a thing. In the last month, the same meeting with the other company I was attending, and as I came out from the Delhi airport, there was a board hanging the board, and there was written that Delhi Municipal Corporation welcome to you. So I was waiting there for 1 hour and nobody came to welcome. So, and one of the taxi driver told that, sir, nobody will come. This is all written nonsense. So then why the people write that like that? I want to say, and when I came at Dehradun airport, it was fine. Absolutely the facilitation and hospitality was good, and people also welcome to me. Actually, when we are working in some of the very remote control areas, you know, like in NATM projects or in road projects. So such type of human satire in the life should be continued. All are professionals sitting here, no doubt, and everybody is expert in his field. But in the spare time, somewhere we should do such type of human satire. Through with that, the stress can be released definitely. And the gentleman, if you are getting after laughing, we are having at the time of lunch 2 chapatis, definitely we will take 3. So now we come to the slide now. Basically, the tunnel IS codes. Oh, I have to. Basically, the tunnel IS codes, that is 4756 10526 5876 and MFPA 502. These are our tunnel codes. Normally in tunnel, why accident happens? Only because of 2 reasons. There is unsafe act and unsafe condition. There are only 2 reasons. There is no reason at all. And in unsafe act, if you are not using the PPEs, not following safety rules and regulations, operating equipment without authority, normally in construction 70% work goes to the civil, 18% work goes to the mechanical, and 9% work goes to the electrical, right? So if we add it, it comes 97%. In balance, that we can say it is going to the act of God, like tornado, scarcity, hurricanes, like that. So 97% incident and accident can be prevented with using whatever we want to use the type of safety gadgets. And definitely the greenfield, yes, yes, sir. ILF already is involved with the transport and structural, all the type of activities involved. The table of contents are that project details of Kachedi Tunnel. There is a project team. The project details of Kachedi Tunnel. There was a tunnel cross-sectional area was 139 square meter. Tunnel height was around 10. Tunnel width was 16, outer dia was 82, and inner dia was 78 meters. Basically, in NATM, there are the sequences, the work sequences are survey and profile marking, yes, the drilling holes, loading, explosive, charging, blasting, defuming through ventilation pipe, removal of mug, scaling, chipping, survey, short crating, support system, short crate, second layer, whatever, systematic rock bolting. So this is the sequence of the NATM tunnel, and in our Kashedi tunnel project, the project team, including execution methodology, was executed. Site photos I would like to show here. This project was of 441 crores. And now the extension already has received by us. There is a extension of up to 23 10 2023. It will complete. And scope of work was construction supervision, review and approval of design and drawing, approval, certification of payment to contractor, monitoring and tracking of progress, construction phase 30 months as I told. Then this was our professional staff, geotechnical, tunnel design engineer and all. So execution in methodology, mobilization of team on construction site office, approval of design, construction supervision, geological mapping after every providing support as per drawing of rock on site, construction of substructure and superstructure of bridges. There were 5 viaducts and 7 minor bridges. Mobilization of team on construction site office, that is all. Basically, the main challenge was this tunnel was faced that already in survey the result comes out, but there was a the first thing was the tunnel portion was very thin, first thing, and the second was after having some channage of near about 1.02 kilometer, there was a pond, and which was ancient and which had not come in any of the knowledge. So later on we came in knowledge. Then on that time the leakages already been started there, and with having the proof methodology, we had to cover that. So, and the second challenge was there uh, in Kashedi Ghat. There was heavy rain, and the rain was already calculated near about 5323 mm last year. So it is a challenge also about raining and all. So this was a very brief discussion about NATM tunnel which we have been completed and supposed to start within few days. Thank you. Sir, it is supposed to finish. Actually, road work is in balance here. Yeah. Already last time the other people have been visited.
This is a presentation. The project case study has been explained by Mr. Praveen Dongre. The project is about to complete. So thank you, Mr. Dongre.
I would like to think you'll find additional information on conference website when it will be distributed a little bit later. As presented, the most compressed version, but there are a couple of additional details which will be worthwhile to pursue in order to get a little bit of more experience about what is being discussed. Thank you. We'll move now to the second presenter, who has been introduced, is Max. Please take the floor.
Sorry, I need to find the presentation first. Here it is. All right. So I got 20 minutes to give you a quite big package about the fixed firefighting systems. That's the topic which has been already handled in different contexts during this conference. And today I'm going to run through a few different parts. I have tried to build it to logical content. First, just a few words introducing myself, where I'm coming from, then a bit more about the tunnel fire safety in general, before moving to fixed firefighting systems and related good practices, and then finalize into a case study from Egypt. I was kindly introduced already as a person, as an affiliation. I just mentioned that the IFAB is Berlin-based company, working very internationally. Our services are typically related to the design and consultancy, but we are more known from the fire testing, and that's probably the role what I'm today presenting. Tunnel fire safety is obviously the topic which is not new thing, and we as Europe are having quite a lot of the bad experience, and the things are not over. But the good news which I'm bringing is that the tunnels, they have become much safer. So there is extensive testing done, extensive research, our standards. We are having EU directive, and we are, as we see, our society is willing to adapt to new risks like new energy carriers. But how we have come to this situation is that we have a few key elements, and some of them they were already introduced here today. So starting about the risk analysis, then having the realistic design curves that we know how to define or design the tunnel safe, which then has to do with the improved ventilation system, correct design parameters for that. But especially with the fixed firefighting system, that's the topic of today. It's a bit exotic, but that's what my presentation is going to be. Not to forget also the operational measures, which actually Ricardo is going to talk later in terms of fire services. But fixed firefighting systems, I mean, that's an awful word. I mean, NFPA 502, there we are talking about water-based fire suppression systems, and there are a lot of different words. But what they really mean is that it's a kind of fixed installation which will interact immediately with the fire. So it's like having the fire services being present 24/7. And important is to understand that since it's interacting the fire, so it's going to limit its size to portion of the potential without having the system, and it will also prevent the fire being propagated to the other vehicles. So that's in a nutshell, that's the operation of the fixed firefighting systems. And we have to remember that many other systems, they are operating or they are mitigating the consequences of the fire. So like passive protection, protecting the structure, or the ventilation is just keeping a safe area for people or fire services to operate. But they don't influence the fire itself. If we are looking that in an illustrative picture, so we see a typical fire curve, so heat release rate curve, with a fire which is not being fought with a fixed firefighting system. And if we are doing the comparison, then obviously with fixed firefighting system, so we are going to cut the peak value, we are going to limit its size. And that's, in a nutshell, that's the operation of this technology. What it do then in practice, we see here one very famous fire. In Real Tunnel, we see another video from the fire tests where we see that how well these technologies in general, how they are controlling not just the fire itself, but also the thermal effects around the fire. So they are cooling the fire, even though there's still a certain number with the heat release rate. And that's what we see what they do in real action in the tunnel, which is equipped with such system. So then the question is that why should we utilize this technology? It's definitely not for all tunnels, but obviously if we have worries regarding the asset protection, so if we have worries that what would be the damages to the tunnel structure, or we have to reopen the tunnel, so obviously this is a very, very novel in that sense. When it comes to the safety of fire services, if there's a long response times and very long tunnels, so again the temperature control, and not just the absolute, let's say, convective heat, but also radiation, that's very important for the fire services, just to approach the fire. And last but not least is obviously the safety of the motorists or safety of the tunnel users. So there's an immediate help with such technology. Okay, what does it then cost? I'm not here to answer it, but just mentioning here some possibilities. So I purposely took a cut from NFPA 502 standard, which basically says that the trades-off are possible. So in case that you know that you're not going to reach, you have a reliable system, you're not going to reach to certain high value with the ventilation design, so potentially you can relax the design parameters. But obviously then you have to have a very resilient system. And also the interaction between the ventilation is a very, very important thing, and I would like to spend much more time, but unfortunately today we don't have this time available. But I mean, we can later on, if somebody has an interest, so we can share opinions and I can share some test data. But it also influenced the passive protection. So in case of having IWS curve or whatsoever, let's say, coming from the higher demand, so probably that can be also relaxed, because the temperatures are not going to be that high with such technologies. I'm not going too much detail, so I'm just saying that there are basically two mainstreams when it comes to different technologies. One is what most people know as kind of standard sprinklers. So when we're talking about deluge systems, so very similar what's been built or what's for longer times in tunnels. And these systems, they typically utilize very, very high flow rates and sometimes even extreme, because there's a very little testing background, so very little fire testing, so people are often playing on the safe side. And these larger droplets, they don't really interact very well with the Class B fire, so with flammable liquids or dangerous goods. So that's obviously one of the shortcomings. Big water quantities are also influencing some technical parameters, but nevertheless, especially in America, deluge systems, they've been used quite a long time. Very little in Europe, Asia, I think few cases, and I think in Africa, I think there's none. The other mainstream, which is really coming more from Europe, is a water mist, and that's more than developed then for tunnel applications. So trying to be very effective in terms of water and pumping it over the long distances, and also it's because of the smaller droplets, it's a very good in cooling, and works also with very well with the flammable liquid, so Class B fires. And this is really the in Europe, I would say mainstream. So I would say 90% of the tunnels are being protected. And in America, I think only 1 or 2 now have been protected with water mist. In Asia, there is both systems, and now today I'm also presenting case study from Africa. If we are trying to look a bit of the parameters, so these are very generic values, and you have to speak then with the manufacturers to get the details. But typically, deluge systems, they are having very big pipes, which probably is not the problem with the very short tunnel, but over the longer tunnels, so pumping huge water quantities, it's becoming problem. In Europe, only the stainless steel is allowed, so also commercially it's not very sensible. But anyways, I think you can do your homework regarding this. I think there are good companies with a good experience with that. But what I probably would like to focus more is then from the designer's perspective, or how do we handle with such systems in real projects. So first of all, in terms of standardization, so there is not really an own standard for fixed firefighter systems in tunnels. Some countries, they have included it to their national road tunnel standards, but it's only for really special cases, so high hazard or high risk tunnels which are going underneath water or something like that. But there are very good guidelines which are also referred then in the standards like NFPA 5.2, and obviously I've been involved to the SOLID research project, and I think that still is, even though it's 10 years old, I think it's probably one of the best, and it's all available from the internet. Also, PIAC has published basically 3 reports on FFS in past. Without really looking into all the technical details, what is probably the most essential is the fire testing. So this is probably sometimes a bit, gray area in certain countries, and contractors, they might propose some CFD validated design and that sort of things. But with such infrastructure, the only good way is to trust only for full-scale experiments. And again, there are some protocols which being guided to be used, but I think that's probably the main takeaway also from my presentation, that not to believe any contractor, any manufacturer, without really coming with the evidence that the system is performing when it's needed. So the design parameters have to be very clear. And then if we try to jump already to a short checklist that what would be the other things, like I said. So fire testing, most important, but then we have to see also in the real project that whether the layout parameters, the nozzle types and everything will then follow technically what was tested in the validation tests. And whether the parties involved, they have a sufficient experience also with that. And then there are contractual issues, and last but not the least, fixed firefighting systems, they also have to be integrated to many other systems. I mean, we can have a Mercedes, but without driver, it will not, take you anywhere. So it has to be coordinated, that it works, it knows where the fire is located, and it will be triggered in the correct location. Then finally, looking also to one case study where fixed firefighting system was recently introduced and installed, and I took Ismailia Tunnel where we were also involved, and obviously this is one of the big investments in Egypt, going under the Suez Canal, and the intention is really to provide for the Sinai Peninsula a new connection, and obviously at the moment it's mainly going over with the ferries, and it's a very gigantic project. And our role in this project was to really check that, okay, full-scale fire tests, ticking the box, but whether that will be then reflected to the design. We actually did this work together with Stufa, so I have to give also the credit also for them for exactly the same work we did together. So we were checking that, let's say, the mechanical installation that will follow for the design parameters which were coming from the validation fire test. Good question is that why did they choose to go for fixed firefighting system? And obviously these tunnels, they are a very important part of the infrastructure. So it's for the material supplies, but it's also from the military perspective, it has a special interest. And they really wanted to make sure that they are prepared in case of fires, and they will have a quick recovery to make sure that the tunnel is available, and obviously the help for the fire services and first responders. Here the selected technology was high pressure water mist. That was the end client and the military who actually chose this. That was how I was told. And here they wanted to have, let's say, a contracting model where there was a manufacturer and contractor very close to each other, and they basically just wanted to have a good one counterpart to speak with. And for us then to check the works, that was also perfect. There was no people that they would escape the responsibilities and rotate our questions. I will not go so much to the system details, but I think just a few things to mention that was high level prefabrication, like with all the other services in tunnels, so made the installation easy, made also the checking of the installation easy, quality control good, and when we were talking also about system resilience, so that already influenced, let's say, the material selections, but also the control systems and having the secured systems. And this is a very important topic when it comes to the project phase. So fire test is, let's say, ticking the box, but then you really have to make sure that you will install a good, reliable system. There was various levels of different checks, and that was I think for me it was it was probably even more than in Europe. Just to summarize here, so regarding the case study, Ismailia Tunnel, so project went very smooth, especially considering its size, complexity. Just normal hiccups were found, but well planned, it's half done, and I think it really worked also here, and for us, and I believe for Stufa it also was a easy project to monitor. Then coming to the final conclusions of my presentations, and let these be then takeaways for you from my part. So fixed firefighting systems are definitely a technology which has been used increasingly, and especially in tunnels which are having some specialities with high risks or huge traffic loads, very important for the society. And fixed firefighting systems, they really change fire conditions as they fight the fire directly, not the secondary effects. And it has to do with the asset protection, short recovery after the fire, life safety and safety of fire services. And it can be also used to relax other fire safety system specifications. High pressure water mist is definitely the most used, I think, worldwide, and it is really coming from the Europe, and it can be used also with Class B fires. What we learned from the Ismailia tunnel is that when we are testing or taking a technology which have a good track record in testing, and we take experienced contractors, manufacturers, and we do high-level prefabrication, high-level quality control. So even with gigantic projects, we can do very well. So thank you very much for your attention.
Thank you, Max, for the excellent presentation. You were spot on time. We do apologize. The last few seconds there, we could not maintain the IT side of things, so you may have lost a few decimal things, but they will come out as we start debating. You can give him opportunity to highlight or should slide again if necessary in terms of conclusions. We'll move now to the third and final presenter. We are doing well on time. That means that we'll have a good time to interact. So this time, it's your friend. Can start.
Okay, thank you. Good afternoon, everyone. Thanks for waiting for my presentation. I will just give you some ideas about what we did in this project in Brazil I presented yesterday, based on the São Paulo firefighting strategy. So this is the longest road tunnel in Brazil. It's a tunnel in the Tamoios Highway. As you can see in the sign, it's 5.5 kilometers long. It's a tunnel with 5% slope going up, so it's quite interesting tunnel to cross the mountains. And we had a huge discussion with the fire services when we started the project, because they started to ask complicated and silly things to us during the design phase. And then we could reach a good point, I guess, to deliver this in a safely manner to the people, for them. So the Tamoios Highway, as I explained you yesterday, it's a very old highway. This is the picture from the construction, and the highway was built by the fire services at that time in, I think, 1920 or something like that. No, 1820 or something like that. Very, very long time ago. And is this shape, as you can see here, the red line. This is the existing highway, a lot of curves, slopes, nobody computed at that time, so it's a terrible, terrible highway. And the traffic was bidirectional since 25th of March last year. This is a type of accident that used to happen there. This is a camera. This truck is carrying gasoline to the city down there, and of course the trucks collapsed. They had a problem. The driver has a problem. In fact, we have a gasoline leaking. I remember 5% slope, so this gasoline is going through the drainage system of the highway and touch the hot parts of the trucks. As you can see now, there's a bit of smoke, and then the fire starts, and the people run out, of course. So this is a type of accidents that used to happen there. Of course, we don't like these drainage fires, very large pool fires inside the tunnel. So this accident happens in 2019, and the tunnels are already in construction. Then the fire service start to ask us how we can mitigate this kind of accident inside the tunnel. In this accident, just the driver died. He had a heart attack, and he lost the control of the truck, and the truck turns over, and we have this fire. And also, this gasoline goes through a river that gives water to the city. It was a bit nightmare, but it's over now. We installed solutions for that. So, as I explained you yesterday, I'll just repeat it briefly for who were not here yesterday. This is the new alignment for the highway. It's very, there are a lot of curves, but the radius of those curves are enormous. It means that it's more comfortable to drive through. So when we discuss about the road tunnel safety, there is this very interesting report from the European Economic Commission from the UN about the road tunnel safety. And this report basically mentioned that the safety in the road tunnel depends on 4 pillars: road users, operational, infrastructure, and vehicles. Unfortunately, we cannot do, as a tunnel designer, as a tunnel operator, anything about the road users and the vehicles, but we have to focus in infrastructure and operations. So in terms of infrastructure, we mean geometric design. We have to design it the correct way. The civil design, how the pavement is, how the cross connections are, how is the tunnel access, equipment and systems. And this must be discussed during planning and engineering phase together with the fire services, because they have to give approval to tunnel be open to the public. So in case of emergency, the first responders, they need given by the infrastructure per pillar access to the location. They must be protected when they are there, and means to fight the fire and to control the situation. And for fire, normally it means water. So the arrangement I showed you yesterday, it's a single tube tunnel, unidirectional traffic, and emergency egress tube parallel on it, with a cross connection at every 200 or 250 meters. So the main emergency response designed for this tunnel, it's used always the parallel tube. So in case of emergency, the fire services, they go to the tunnel entrance. We call it the emergency holding point, EHP. And from then, they enter in the tunnel, not by the main tubes, but they use the parallel tube, the safety tube, and using one of the cross connections, they can approach the fire and fight the fire itself. It's important to know that this tunnel, it's a 5.5 kilometers, so they are, let's say, if the incident is in the middle of the tunnel, they are 2.5 kilometers far from a safer place. So we have to give them a safer haven to be when they are in the tunnel. So normally the emergency response is made by the fire trucks. So they enter through the emergency egress tunnel, and then they cross to the main tunnel to attack the fires. I would like to show this picture. It's a very interesting picture. I guess most of you know it. This is not in my tunnel, of course. This is in the Gotthard tunnel. But this picture, as you can see, it's a very huge fire. We have a huge fire load here. But this picture was taken using a normal camera by a guy who arrived in the scene, and he's very close to the fire. So how this guy could be there like this is because this guy is protected by the ventilation system. So the ventilation system plays an important role in terms of emergency response. Because if the ventilation system is not giving them this kind of situation here where all the smoke and mostly part of the heat it's blowing out not against them, but far away from the firemen could not approach the fire to fight the fire. So this is important to be in mind. For this reason, we decided in Tamoios to use a 200 megawatt fire as a design fire, basically because all kinds of dangerous goods are allowed in the tunnels, and you have 5% slope that it's a bit dangerous. So in this case, we can make sure to the fire itself so they can approach the fire in any case. So just to make some ideas how it works, for the shortest tunnels, 1, 2, and 5, the system is full longitudinal ventilation. It means in case of fire, we have a protected zone between the tunnel entrance and the fire itself, and a non-protected zone from the fire on. But as I told you, this is a unidirectional tunnel tube, and so probably there is no one after the fire. In case of tunnel 3/4, that it's 5.5 kilometers, the fire services regulation in São Paulo asked for smoke extraction point in the middle of the tunnel. So there is a smoke extraction station, a ventilation station more or less in the middle. And this is with the idea to create a smaller non-protected zone in case of a fire. And how to fight the fire itself. So, of course, we need to give them water and resources. If you don't give them resources, it's impossible. So in this case, we follow the São Paulo regulations that ask emergency points at every 60 meters. And these emergency points, they have basically a fire extinguisher that is for general users, a fire hydrant that it's a double and can each coupling could deliver 1,000 liters per minute at between 60 and 100 meters of water column of pressure, hoses and emergency phones. But interesting thing is that the fire services asked us to put the hoses in the tunnel. So we have more or less 2,000 hoses in the tunnel system, but they don't use it because their standard procedure is to bring their own hoses. But if the hoses are not there, they can apply a fine against the tunnel owner. So it's a bit funny. Yeah? So where does water come from? We are in the middle of the forest, so there is no public water system. So we have a huge reservoir with 240 cubic meters and a pump run to give pressure to the system. The beauty of the system is that this pump room is 700 meters altitude, and it's on the top of the hill, so we have, of course, the gravity doing the biggest part of the job, so we don't need very big pump rooms. So, be back on this graph that I really liked, speaking about the operation. So, first pillar was infrastructure that was discussed with the fire services during the design phase. And the last pillar is the operation. So operation means we need tunnel operators, and these tunnel operators, they must know how to behave in any case. So they must be very well trained. Unfortunately, we cannot put in Brazil engineers to operate tunnels. The salaries for tunnel operators are quite low. So we try to get the most qualified people as we could. Of course, standard procedures, as I really like the presentation for Helene this morning, because have a standard procedure for everything. It's the solution, for example, airline industry found to have the safest means of transportation. It's not because the aircraft, it's because the procedures. Everything is follow procedures to build aircraft, to design it, to buy and to operate it. So standard procedures is the key, in my opinion, for this. Of course, this includes the emergency response plans that are prepared together with the fire services. And it's important thing to point out here is that normally the fire services, they are trained for fires in buildings. They don't know exactly how the fire and smoke behave in a tunnel. So sometimes they ask silly things like, can you please turn fans in the opposite direction to extract the smoke for both tunnel portals? And I told them, okay, this is not possible with this solution. To do this, we need a different kind of ventilation that's not designed. So it's important to have this conversation with them to show them how the system works and to prove them that it works and how they have to operate in case of emergency. Of course, the resource, continuous training and practice, and again, the PDCA that was presented by Hélène, that it's an important process to keep going this in practice. So this is a picture of drill the fire services did. So they tried to put their personnel inside the tunnel just a few weeks before the tunnel opening. They are using in this case all the tunnel equipment. Though it was the first time the São Paulo Fire Services use equipment that is not bring by them. So they are not using their fire trucks or the water. They are using the tunnel system. And also, they tried a different approach into how to do the triage of the victims in the parallel tube. So basically, they bring victims from the main tube to the parallel tube. This picture is taken by the parallel tube. This is a drill. It's not a real emergency. And they trained how to put people there and make the triage of the victims there, and then bring them to outside the tunnel, give the priority they need to do. So this is a small video about this very short video, just to show you when the system starts the ventilation. That's the normal ventilation given by the mountain. The mechanical ventilation was against it, so it shows that. And also, from the other side, just to show you that this was really nice because of the fire services. They didn't know that the system reacts like this. It's a bit funny, but at the end, just this is very small smoke bombs. They gave them a very good idea about how to behave, how the system behaves there. So in case of in this case, it was a joint training between the concessionaire, that is Tamoios, the road policy, and the fire services. And they also used the helicopters to go there and to, of course, not inside the tunnel, but near the tunnel portals to rid off the victims. Another important thing is to training the personnel from the tunnel owner. It means all the tunnel patrol officers, the toll guys, the guy who do cleaning, they need to do how to behave if emergency happen in the tunnel and if they are there, and how to fight a small fire, because they are our own employees. So we give them very nice instructions inside the tunnel. That's another good idea, to bring them to the tunnel, to feel the tunnel and look the equipment and see and smell the tunnel, smell smoke in the tunnel. So this is something really nice also to do, and we did that. This is a picture of the testing we did. As you can see, there is a huge number of firemen here. All the headquarters of São Paulo Fire Services went to the tunnel these days. And this was a testing to prove that even for a 5.5 kilometers, a full longitudinal ventilation system, it's able to cope with the smoke and heat they can encounter in the tunnel. So we basically used the Austrian standard to do that. So we put two small pool fires, we protect everything, and then we can prove that the system works. This is, oh, it's not working. So this is just a small video to show the fire, but let's try again. No, the video is not running. I'm sorry. But this is another important thing. I mean, you have to test everything, and the good part of it is to bring the fire service to the test, not only the engineers, also the guys who are about to fight the fire, to have a contact with how the smoke and heat it's behaving in the tunnel and how the ventilation can cope with that. So just a few ideas. This presentation was made together by the captain of São Paulo Fire Services, Diogo Diniz. Unfortunately, he could not attend the conference. Thank you for your attention, and I'm available for questions.
So let me thank all presenters for their outstanding work. We did beautifully in terms of time management. Ricardo had still 2 minutes to use, and he chose not to. So here we are. Pravin Dongre was the first to bring the concept of unsafe act or unsafe conditions which need to be taken into account. Max brought us the concept of fire safety research and results associated with that, and the application which has been in place for the last 12 years. And of course, Ricardo brought the Brazilian experience and different exposure, all fire brigade, fire teams, but outlining 4 key parameters which related to road use, the operations, the vehicles, and of course the infrastructure which many of us are responsible to design. It's open out to questions. We have time. We can start. Who would like to be the first? I can see many hands up there. Please. As always, you'll identify yourself, organization you represent, and indicate to whom you address your question. Thank you.
Yeah. My name is Sunit Dhar. I'm a freelance consultant for the tunnel ventilation and the fire safety engineering for the tunnels. My question is to Mr. Max regarding that Islamia tunnel, the mist system which has been used, whether there is any specified dimension for that mist particle, so that at the high temperature, obviously above 250-degree temperature, it should not be a steam generating into a steam or a superheated steam. So is there any approach to
That definitely is not, and normally in projects you don't specify a droplet distribution or any droplet diagram diameters, but you normally specify that the system has to be tested, and you specify then against what kind of fires the system has to be tested, whether it's a class A and class B, and what are then for example, against 150 megawatt class A fire, heavy goods vehicle, or class B 100 megawatt, and that's normally where you then take the results. If you want to go then to a detailed, let's say, discussion about the design parameters, then that's going to be then the aftermath, which is based still on the experimental results.
Thank you.
Yeah.
Do we have more questions?
Yeah, I do. My question is with Ricardo. In the last slide, what you have shown, that is a fire taste between like 2 tastes were there. When we are taking the fire taste at that point of time, usually what sort of, in terms of megawatt fire we used to, or rather we should create, that can give the more better idea whether the ventilation system is working in a proper way or not. And do we have any standards specifically for this tastes where we need to follow, or either any sort of document is available on PARC or anywhere, or if you have?
Yeah, we are working our standards in Brazil for that, because just to be back to your question. It's funny because the fire service asked us in the beginning to put there all the car structure and catch fire, but in my opinion, an empty car, just metal, is not giving you anything. So what we decided, we looked around the world and we found this Austrian standard, the RVS something, that means that you have to test, this is the minimum fire you have to test, not only the smoke control and heat control, ventilation I mean, but also the fire detection. So with this fire test, we test the detection, we test the time of detection, if they detect or not, and also the smoke management during the emergency planning. And what fire services ask us to do is in the middle of the test, they ask us to reverse the system to check how much time it takes for the smoke to have a free smoke zone downstream the fire, let's say. So, but we use the Austrian standard that it's, in my opinion, sufficient to do a test like this. Don't try to do anything bigger than that because you can damage your tunnel. This small fire already did small damages here and there, but in my opinion, it's enough because it's about, if I'm not sure, it's a 3 megawatt or something like that. So it's 3.5. Not that bad, that big, but correspond to normal passenger cars, I guess. Am I correct, Peter? Okay, sorry. 3 to 4, yeah.
So while having a taste, we have to create a 3 to 4 megawatt of fire? That can be created with the table?
Yeah, there are two pools, 1 square meter each, 20 liters of diesel, 5 of gasoline, if I'm not wrong, and then we catch fire in both at that same time. There are not the good things that this amount of the gasoline extinguishes itself in 20 minutes. So it's a very short test. If something gets wrong, or if the pool falls on the floor, nothing big happens. So in my opinion, it's enough. But Peter, please.
No, you said everything. It's roughly 3 to 4 megawatt fire. It depends strongly on how big the air velocity is, of course. But this is the standard test we developed roughly 20 years ago or 30 years ago, 20 years ago, I have to say. And it's widely used. The problem is only that afterwards, if you have a nice tunnel, you have to clean it once again because it's a lot of smoke which you produce.
Yeah, and any international standard is following by that?
Pardon?
Any international standard? Or IEC,
No,
not
no,
IEC,
there is no international standard for such tests, and definitely not for tunnel tests, and that's the reason why we developed this test. And this test is mainly to see, as Ricardo said, it's mainly to see if your ventilation control is working, if your fire detection system is working. This is the main issue, because 3 to 4 megawatt is not a big size for a tunnel ventilation system, but just to see if all elements of the system are working properly. And
done. Tunnel ke liye ventilation proper chal raha nahi.
Do we have more questions?
Thanks.
Ernest Poon from Land Transport Authority, Singapore. I have a question from Max. Do you have a preference between high pressure water main system and low pressures? And I guess on my side, at my end, we did a few tests. Seems like the low pressure water main systems appears to be using a less lower capacity pump and require a lower drainage systems to handle if there's a fire situations, and the performance will be the same actually in terms of suppressing the fire size.
There is, I think the problem is that there is not really direct comparison. Tunnel Mont Blanc, we did actually the direct comparison, deluge, high pressure and low pressure mist, but normally you are varying some of the test parameters anyways. So therefore it's difficult to say. When it comes to the technical details, that's what I was saying, that it's really related to the country, that it's not just that sometimes even deluge can be good if it's a very, very short tunnel. If the tunnel is longer, then if you need to go for larger pipes, then the commercials might play a different role.
Sorry, Max, I think you get me wrong. I was I was talking about the high pressure and low pressure water main systems.
You mean the difference between the high
Yes,
and low
yes,
pressure
right.
system in terms of the fire test or the real installation? Is that
both?
Both. Well,
Fire
from
test, I mean, fire test would be like, no, the performance could be the same.
yeah, fire test for the performance, but as I said, there is not the direct comparison with the high and low pressure water mist system.
All right.
As far as I know, the only one is that which we did for Tunnel Mont Blanc, something like 10 years ago, French research project. So that's question number one. And question number two, regarding the installations. I think that in the installations there are so many different variables, not just the flow rate, but it's the pressure. So I mean, we are having, where I've been involved personally, is the longest tunnel is over 50 kilometers. And you know, with the high pressure you are obviously able to pump waters over long distances just with the simple pump stations. But you know for sure from your projects also that sometimes, you know, it really varies, and whether you need to go big pipes or smaller pipes, and this is the technical comparison. I think I can't say that I would favor one or the other, but I'm just saying that in Europe, probably definitely the most cases are with the high pressure water mist.
Okay.
Traditionally.
Okay, that's great.
Yeah.
All right, thanks.
I'm going to take opportunity also to throw up one or two questions to Mark. The first one, you did highlight that, you know, Solid 2 was one of your best, you know, effort in terms of design and testing at the time, and has been in place for some years now, 10 years. My question is, have you done some additional refinement? Did you add any additional research into it? Or you concentrated on enhancement of solutions which you derived at the time? That's the first one. And the second one is to provoke you a little bit more. You indicated that the interface, you know, at the moment there's so much effort in design, you know, CFDs are coming nicely, but there's nothing sufficient about having a good design, but without testing. So you indicated designs are coming well, but testing is still essential. What does that mean? Should we test every single tunnel, or your knowledge and experience coming from the past is sufficient to help us? If you have appropriate information coming on CFD, then you can apply your knowledge to deliver the results, you know, tunnel users need. Thank you.
Okay, that's a lot of the answer, but let's start with the first one. So, I think Solid 2 was already quite substantive, and I think afterwards there have been some project-related tests, and there has been by some of the operators. But I think that the fundamentals are there, and the trucks, the lorries, they have not changed too much within the last 10 years. So I think in that sense, it's all valid. Data, it's valid, and if we are looking even to the history, how we ended there, so there was a very rapid development, but now I think it has kind of stabilized, and then we are more discussing about some technical details nowadays. But then when it comes to your second question, so yes, there are certain similarities between all tunnels. When it comes to the fire load and whether you are having heavy goods vehicles, not heavy good vehicles, flammable or dangerous good, not dangerous good. But so I think you can apply, let's say, generic tests, generic data in that sense. But if you really want to go for some detailed things using the CFD, so for sure, if in this field there has been also a lot of knowledge happening, and for example, the interactions between the ventilation and fixed firefighting system. We actually did for Federal Highways Administration big project to America, exactly the study, the the interface between the ventilation and fixed firefighting system together with WSP. So there is a lot of knowledge happening, and to the last part and about the integration interfaces. So that's, I still would like to highlight that in the same way like you're testing with these pool fires, the detection, but the detection has to also control fixed firefighting system. And it's a complete safety system which includes also the fire services. They need to be alerted, and this is important part of the commissioning of any of the safety systems.
Thank you, Max. I think you have been extremely helpful to me and to the rest of the participants. We've been doing well on time. I'm going to pass it on to my co-chair to outline final key points so that we'll be spot on time. You have 4 minutes to conclude, and there's a prize for that.
Thank you, Mr. Thiago. The first presentation was by Mr. Praveen Dongre regarding the Kashedi tunnel. He has given the outlook of difficulties faced by them during the construction phase, and excessive rainfall, as this Kashedi tunnel is located in the Western Ghats. It is extensively rainfall area regarding the monsoons, and he has given insight into the working of that area and difficulties faced. And one surprise pond has been discovered that has been given, and tunneling is a subject where surprises do happen many often. So this is one of the presentation. Now the second presentation given by Mr. Max, it gives insight into the fire safety, and it is a eye-opener for the developing world, because we do have course correction based on the case studies previously done by the executing authorities elsewhere in the world. So he has given a very bad experience. He has shown one of the accidents, and that too in a gasoline tanker. So that has given a very good experience per se for considering into the fire safety in the Sao Paulo much safer. Key elements, fixed firefighting system. Sorry, I mixed up. I'm extremely sorry. Mr. Max has given the key elements in the fixed firefighting system, and the basic details of the firefighting system of fixed pattern shown on the graph. The dangers coming out of the fixed system was minimized because of the having the fixed firefighting system. The asset protection and safety of motorists were insisted upon. The ventilation part was defined that it is a basis for the fire control, and sprinklers and their cooling in IFAB systems. The best part was told that not to believe the contractors and suppliers without having evidence of the system foolproofness. There was a short checklist, and under the Suez Canal, the Sinai Desert Tunnel, the case study was shown as a third party, third party the convenience of the suppliers and the third party testing importance was insisted upon, and we can learn a lot from them. The third presentation was Mr. Ricardo at the Sao Paulo firefighting strategies. There one accident was shown, and report of UN EFC road tunnel safety was implemented, was considered to be important for the Brazilian system, and emergency system of 200 megawatts firefighting fire strength was considered for the firefighting systems. Water reservoir under gravity was the crux of the fire safety and tunnel operations. Safety drills for the training of the personnel and the firefighters was insisted upon, and that was a learning for the before tunnel into operation. The drills for the safety and fire systems to be functional was considered very important. So we can learn a lot from the experts. Galaxy of experts available here. We can we are going to enrich this our experience also, and I expect to be enriching experience for our country as well. Thank you, Chair. Thank you so much. Chair.
And I think this is, with this few words, is the conclusion of our session. And I want to thank everyone again for your proactive contributions. I want to thank our speakers for the outstanding work. And I would like to invite you to give them a good round of applause, please. Thank you. And I hand over back to the moderator and task manager. Thank you.
Thank you, sir. Thank you, sir. Now that we are done with the discussion, questionnaire, conclusion of our session 6B, we declare this session 6B successfully concluded, for which I thank our chair and co-chair for handling the flawless flow of our seminar, and the respected presenter to present all the knowledge so perfectly and concisely. To thank which, I request Dr. Mr. Pareda, Vice President IRC Director, CSIR, CRRI, New Delhi, to come up and felicitate our chair, Mr. Tiago Massingini, PIARC Technical Committee 4.4. Our co-chair, Shri V.S. Khera, Chief Engineer, Morth. Our respected presenters, starting with Mr. Praveen Sudhakar, sir. Moving on to Mr. Max Lakanen. And completed by Mr. Ricardo Miranda. I thank all the dignitaries to be present here. Thank you for being with us. After a successful discussion, now I declare this session for a hiatus again and request everyone to enjoy the lunch with us at the Vedanta Reception Hall. We shall convene once more for the last time at this same room, exactly at an hour's gap at 2:30 p.m. for our last session, session 7B. I thank everyone to be here. See you. Hope you have a great day.
चेयर और को चेयर को करना है ना रमशीद पादशाह PADUSH
हाँ
PADUSH
हाँ
ठीक है एग्जीक्यूटिव इंजीनियर मौत
हाँ
एग्जीक्यूटिव इंजीनियर मौत एग्जीक्यूटिव इंजीनियर एग्जीक्यूटिव इंजीनियर मोर्थ ओके ओके मोर्थ तो मिनिस्ट्री ऑफ रोड ट्रांसपोर्ट एंड हाईवेज पॉलिटिकल तो कोई भी नहीं बोल सकती सो स्टार्ट नहीं जस्ट टू वेट लेट्स देख 2 मिनट और वेट कर लोग बहुत कम है ना
उनका अनाउंस कर दिया था 2:45 आई अनाउंस 2:30 एक्चुअली
हाँ 2:30 है पर उधर भी डिले चल रहा है आज
या
1 मिनट के बाद स्टार्ट 1-2 मिनट के बाद अभी मैं देख लेता बायोडाटा कैसे डिस्प्ले कर रही है वो कर रहे हैं क्या उनके पास नहीं है वो
सिग्नल कर देना स्टार्ट
Good afternoon, ladies and gentlemen. It is said, believe we can, and we are already halfway there. With this belief in our hearts, we have reached the final session for our day. Previously, having discussed about risk managements and case studies on road tunnel projects, continuing that, we move forward with our seminar through the session where we pivot all our attention towards case studies on road tunnel projects, part 2. We glide through this session in the presence of our chair, Shri Sudeep Chaudhary, Additional Director General, MORTH, and our co-chair, Mr. Namgu Kim, PIARC Technical Committee 4.4 member, South Korea. While we'll be focusing our contemplation towards the understanding of presentation on Annie Cordy Tunnel, refurbishment and modernization of the Brussels Road Tunnel Control Center by Arthur Kabuya, PIARC TC 4.4 WG1 leader, Belgium. Moving on from that, we'll be presenting on stormwater management on road tunnel / Penang undersea tunnel by Mr. IR Chand Sai Chok, MD, Perunding Eagles Engineers SDN BHD, Malaysia. Later on that, presenting on road tunnels controlling in the center of Prague by Mr. Lucas Rakosnik, PIARC TC 4.4 member, Czech Republic. We will now move forward with this session now that our chair, co-chair and fellow presenters have already joined us. I simply request Mr. Ramshid Padusha to come forward, our executive engineer Moth, to felicitate our chair and co-chair. With felicitations done and greetings processed, we now hand over the stage to the for the procession to our seminar to the respected committee.
Good afternoon, distinguished delegates. The co-chair, Mr. Namgu Kim, and the presenters here, Mr. Arthur Kabuya, Chan Sai Chok, Mr. Ayar Sanchai Chok, and Lucas Rakosnik. So it's a privilege on my part. We have had very interesting sessions so far during the two-day proceedings. A lot of learnings here, and we want to basically translate this into an actionable plan. We are coming up with very exciting projects in India as well. So basically, the things that we have been looking forward to, our minister also had emphasized during the opening sessions that he had joined us virtually yesterday, that having embarked upon the decision to take up so many projects, now we want to basically strike a very delicate balance between how much time we need to basically spend for detailed engineering and then go ahead with preparation of detailed planning of the activities for designing as well as implementation of the projects, and most importantly the operation part of it. So I understand today's session is basically focused on the operation and maintenance part of it. And very interestingly, in today's morning session, the lady, I just could not recollect her name, a very interesting sentence she said, that if we fail to plan, then we plan to fail. So that is what the adage is all about. So sometimes we have a tendency of basically putting the cart before the horse. We are trying to struggle too fast, basically maybe trying to do things in a very hasteful manner. So to cut out all those things, that is the plan. Basically, now we are congregating here to understand what are the nuances, what are the main core areas that we need to be focusing on. So without much ado, I will request my co-chair now to invite sequentially the presenters to get ahead with the presentations. Thanks.
Good afternoon, ladies and gentlemen. It is my pleasure to be here and to have you this kind of fruitful seminar session 7B, Case Studies on Road Tunnel Projects, Part 2. I hope this time will be helpful and fruitful to all of you and all of us. Thank you. So
the first presenter, Mr. Arthur Kabuya. So I invite him to take the dais now and get ahead with his presentation, please. Your time scheduled for your presentation is 20 minutes. Kindly adhere to the timeline so that we have enough time for interaction.
let me introduce Mr. Arthur Kabuya. He is a civil engineer in electromechanics and master in management science, and he joined Brussels Mobility in 2000. For more than 20 years, he has mainly been involved in the maintenance of tunnels and renovation projects. He has participated in the PIARC Road Tunnel Operation Committee since 2006, where he is currently the coordinator of the Working Group 1 and Working Group of the TC 4.4. Now he is a member of the General Council of the Belgian Road Research Center. Please give warm hands to Mr. Arthur Kabuya.
Thank you very much, Kim, to
introduce me. And first, I would like to thank Ministry of Road Transport and Highway of India, and also to thank Indian Road Congress, and also the sponsor of this seminar, to give me opportunity to come here in India in order to share our experience of Belgium with you in the field of refurbishment of tunnel, and also in the field of modernization of our control center of our tunnel. And I would also thank you for your hospitality, good food, and also for your the events of yesterday, the cultural event. Thank you very much. I will present you today the project of Annie Cordy, and also I will give you information about the modernization of our tunnel control center. And first, to present you the project of Annie Cordy, I want to give you the context and also the history of the renovation of the tunnel in Brussels. The context is that my administration, Brussels Capital, manage 26 tunnels in Brussels. Tunnel Annie Cordy is the longest, 2.6 kilometers. And my administration manage also the network on the surface, and we work also in collaboration with the control center of the metro, the bus, and the tramway. One thing is important to know is that our tunnel, their age are in about 60 years, and many of them present growing sign of ageness. The history of the renovation of tunnel in Brussels, from 2009 and to 2016, we have a major incident in Brussels. In Tunnel Annie Cordy, we have the wall fall down because the edgeness of the tunnel, and also the piece of concrete fall on the floor. And in the same time, we have no chance. We have the problem of collapse of the structure in the tunnel Montgomery in Brussels, and also in the tunnel Stephanie. In that time, the tunnel Stephanie and Montgomery was closed, and we have a lot of pressure from the media to the government, to the parliament, and the pressure, a big pressure from the opposition politician to the government. And in that time, the previous minister and the previous director general of public work and myself, we went to the parliament to explain why we be in this bad situation. And after a long debate between politicians, and they decided to make recommendation, and in that recommendation, they share responsibility of this situation between the politician and my administration. But we know why we was in this situation, The problem was that the politician and the government don't give the money from the maintenance, and also in early time, in the time of the construction of our tunnel, the choice of the material was not good, and also we think that in that time the administration don't control the work. In the other hand, in the same time, we has not changed, because in 2016 we had a terrorist attack. With that terrorist attack, we have in our metro and in airport, we have 32 dead and more than 300 injuries. What happened in that time? I tell you, our control center worked also with the control center of the bus and the tramway, and we were not prepared to that attack. And in that time, the communication between our tunnel control center and the control center of the bus was overloaded, and also all communication failed. And in the debate at the parliament, they asked us to build a plan, a strategic plan, to renew the tunnel and also our control center, and in synergies with the control center of the bus and the metro. Yes, after we built the strategic plan of renovation of the tunnel, and this plan has the budget of tunnel renovation, budget of tunnel maintenance, budget of control center, budget of safety documentation, budget for safety officer, and so on. And we put also in this investment plan the budget for exercises for fire brigade, and also for the person working the control center. Here you can have an idea of money we spend each year for the tunnel renovation. Each year we have a budget about 116 euro for the renovation of our tunnel. For the renovation of tunnel in Brussels, we put in place a regulation. This regulation is based on European directive, and additional requirements come from a UK directive and also French directive. Why you put it in place is to harmonize the concept of safety during the process of the renovation of tunnel in terms of equipment, civil engineering, and also in order to have the same operational strategy. Come back to Tunnel Annie Cordy. This is the future of Tunnel Annie Cordy. It's 2 tube, 2 line, 80 vehicles per day. This is the program work of Tunnel Annie Cordy. The program contains fire ventilation, new sanitary ventilation, technical room, additional emergency exit, new emergency niches, renew the roadway, put new protection of fire, renove all safety equipment, and installation of fire protection. This is the figure of new extraction and also emergency exit. This figure shows you the work for repair and protection of ceiling concrete. We use a cathodic protection to repair the concrete. This is the planning of work. The work take 47 months, and we did the work under operation. It means that the work was done in partial closure. We closed the tunnel only during the summer holiday and during the school holiday. And all work was done during the night. This strategy takes a long time. It's very, very complicated to put in place, and also it costs a lot of money. But the decision was the political decision, because the politics don't need to have complaint from the residents, and also they don't have to stop the activity, economic activity in the town. The tender for this project was a PPP strategy. And why we take the PPP strategy? Because in the beginning of the project, we don't have any idea was the structure. That's why we prefer to transfer the risk of the construction to the contractor, and we handle only the risk of permit of the construction. This is the scenario of finance of the project. In the construction phase, we pay about 250 million euro at the end of the commissioning of the project, and during 25 years, we will pay about 10 million euro. This is the project team. We have the public authority in the team of the project. We have also consultants in the project, consistent in technical aspect, financial aspect, and juridic aspect, and also the private partner. For doing the work of Tunnel Hardy-Cordy, we put in place accompanying measures in order to avoid congestion during the renovation of the Tunnel Hardy-Cordy. The accompanying measure was based on public transportation, specific car guidance plan, road redesign, work coordination, park and ride. We put the parking near the central of the station of the metro in order to allow commuters to leave their car at the place they come to come with the train, and to come with the car outside the town to park and to take the metro to come to their work. We put in place communication and also regular debriefing on measure effectiveness during this phase. I go fast. We put also a local nuisance reduction. It was limit work zone, monitoring vibration for the building of the residence. Also, we pay attention to cyclists and pedestrians to access to the zone work. We communicate to social media to give information to the user. We did flyering, and we put in place a sort of mediator to take the complaint of the resident in order to avoid problem with them and the problem with the politician. This is a slide show we use building information modeling in the process of tender in order to calculate the cost of the project. BIM model was used also in phase of the construction and also in commissioning phase and so on, in order to have a predictable construction, limit downtime and failure costs in the project. This is some picture of the first work. I go very, very fast because I must move to the project of modernization of our control center. I tell you, in the beginning time, we have a problem when we have a terrorist attack, problem of communication of our control center, the center of the bus and the tramway. This modernization, this objective was to put new equipment and also to make synergy with the two control centers. This is the history of our control center. We have a big evolution between 2008 and 2019. The objective of the project was to make synergy between the two control centers, to put redundancy in our control center, and also to put a new equipment in terms of ITS and smart mobility. The project budget is 1.5 million. We put new equipment, platform as a service, storage as a network, LAN, network, Wi-Fi, and post of operator. And in the same time, we double our control center. This is the organization of the project. We have two teams. One team works in building and facility, and another team works with a problem of software. We identified two risks for this project.
Another 2 minutes, please.
Yes, two risks: lack of personnel and the lack of guide for this project. This is the strategy we use for this control center establishment and analysis of needs and feasibility and ergonomy of study, and also development and testing phase of new management software. This is the view of new control center. This is the new control center. This is the architecture of this control center. You have a virtual machine, and also all the equipment, the number of equipment was reduced, and all supervision, SCADA, and all the software was put in a virtual machine. This is the picture of a virtual machine. This is a view of this new center. In this center, we have 4 technical and traffic operator, 24 hours, 7 days, 2 supervisors. They follow up the alarm in the system and also to initiate maintenance operation. We have also 1 person deal with traffic analysis in order to put the management mobility plan. We use virtualization of the machine to double, to put a backup of our control center. In fact, we have 2 control centers, 1 main, 1 backup. And for conclusion, we put in place for this project a team with 5 teams, 1 team arrangement of center and the annex, 1 team of center and technology working together, common management. And what is important is to pay attention in transition period and analysis of operating risk during migration system. What the message? The message, I understand, yes, yesterday from your authority was that India want to build a construct tunnel with low cost and without to compromise safety. I think for that you can find a lot of material in our working group and TC committee. We have a lot of previous rapport deal with cost reduction, and if you want to have more information in strategy of refurbishment of tunnel and also design of tunnel, we can find this information in a report we published this year in January about good practice on maintenance and traffic traffic management. Thank you very much for your attention.
Thank you, Mr. Kabuya, for adhering to the timeline. So now I request the next presenter, Mr. Ayar Chansai Chok, to kindly make his presentation.
Engineer Chansai Chok is a qualified professional engineer. He graduated with a degree in electrical engineering from the University of Memphis, USA. He also holds an MBA from the University of Bath, UK. He set up his own engineering M&E consultancy firm 25 years ago, and it is currently the largest M&E firm in Malaysia, with 100 M&E engineers strong. He has over 30 years industry experience. He designed special projects including toll collection systems, traffic control and surveillance systems, ports and harbors, floating city infrastructure, data centers, hospitals, airports, tunnel M&E systems, and metro railway system engineering works. He has completed 80 tunnel M&E systems design works in many countries. Significant tunnels include the 5-kilometer smart tunnel, Penang 10-kilometer undersea car tunnel, 58 car tunnels in Saudi Arabia, double-track 3-kilometer railway tunnel, and metro underground tunnels in Malaysia. Please welcome Engineer Chansai Chok.
Thank you. Thank you for the organizer, for the chair and co-chair. Good afternoon, everyone. You know, Malaysia and India share many things together. In Malaysia, we have more than 3 million Indians, and I'm a Chinese origin. We have 6 million Chinese. You know, Malaysia being a small nation, we have to do things that are significant so that the world will know us. Malaysia just completed the second tallest building in the world, 118 story. We used to be very famous with the Twin Tower, tallest in the world, but it is overtaken by many tall buildings. Similarly, as a small company, I'm the founder and owner of the company. In a small nation, I have to do things that are significant and must be of engineering excellence. We have implemented the smart tunnel, the only tunnel in the world today that is dual function. It's the longest stormwater flood tunnel. Let me give you a very brief understanding what is a stormwater tunnel. In Kuala Lumpur, we used to have flood 15 years ago. Whenever heavy rain, we have flood. The whole city flood. So we come up with an innovative solution. We built a tunnel to store the water when it floods. So meaning that we have a retention pond on one end, collect the water, and the other one is the other end, and the tunnel being 10 kilometers, we will store the water for certain hours so that the city won't be flooded. So it's the first in the world. We follow all the standards, okay, of PIAC and all the world standards. What are the design challenges of such tunnel? You may ask, what happened if the flood happened and car inside the tunnel? What happened is, within 6-kilometer radius around the city, we have weather sensors. This weather sensor will give a signal to close the tunnel. 6 hours before the flood happened, the tunnel will be closed. all the car will be evacuated. So meaning there is no chance the car inside the tunnel, no chance. Because once we clear the tunnel, the flood, of course the weather sensors are very accurate because it's a proven meteorological information. When the tunnel is closed, heavy rain came, we open the floodgate. So the whole car tunnel will be flooded with water. So the challenge is all the equipment in this section of the flooded section of tunnel must be IP68 and must withstand a pressure of 25 meters for 24 hours. Because the flood is normally a few hours, but we have to open the tunnel after 24 hours. That is the challenge. And the flood water cannot surge up to the ground. So therefore, every opening inside the tunnel must be properly sealed. All the M&E equipment inside this section must be designed for water to flow through. It cannot be a hindrance to the water. That is the challenge. Everything must be watertight. Now these are the safety principles. We follow the PIAC standard or the world standard. Basically, I will not read through the slide. It's all in the souvenir program. We follow all the safety and evacuation strategy. The tunnel ventilation scheme, now because it is both used as a water tunnel and car tunnel, we cannot have fan inside. So we have to design using what we call a full Sacado nozzle ventilation system. We use a Sacado nozzle to blow the air, high velocity air, horizontally to ensure the airflow. This Sacado nozzle concept is used widely in Metro Detroit and also in Singapore Underground. These are the case study. Yeah? Okay, these are pictures of the nozzle. Basically, the tunnel got 3 layers. First is called upper deck. Second is lower deck. And then we have the bottom deck is the flow of water. So meaning that in a normal day, the lowest deck, water flow through. It's only when KL, the city flood, the 2 upper deck and lower deck will be flooded. And it used to store the water. Okay, these are the Sacado nozzle. The Sacado working principle, for those who are expert here, I don't have to explain. These are the picture. Now there's only 3 kilometer section that is used for the water and car. Then you have the exit and entry portal. We can use the jet fan. We design, there are many modes: normal mode, congestion mode. Okay, these are the various mode, incident mode, all the various mode. Normal, we provide surveillance. These are the M&E provisions. We follow international standards. Now, let me share with you now, not in the slide, how my company won the job. The original design was done by an international firm, not a Malaysian firm. But because when my client called a tender, it burst the budget. It burst the budget 30% for the M&E, MEP. I throw a challenge to the client. Let me do value engineering. If I cannot save 20% on design, 10% on project management, don't pay me a single cent. That is the challenge I throw. My company wrote a letter black and white to my client. I can save 20% on design, 10% on project management. Obviously, at no cost. Of course, what is my reward? I share the profit. 10-20% of the cost saving. I managed to save more than 10 million US on MEP for this tunnel. That is the challenge. My client retained the international consultant to check on my design. Make sure I don't cut the design. Make sure I meet the international standard. So there's another challenge for my firm. And I did it successfully. I make the money. So with the successful of smart tunnel, I bid for an international tender in Saudi Arabia. There are 40 international firms bid for the project. I won it. My company won it. 58 tunnel in Makkah. 58. I did the design. So that is the success story of my small company. So with that, I also won the international bid for the Penang Undersea Tunnel. Now we are going to implement this tunnel. It will be the longest undersea tunnel in Malaysia, and it will be the longest in Southeast Asia. This, I am the consultant. I am not the value engineering consultant. So I welcome any consultant come and challenge my design and put up the same challenge. Okay, these are the ring road. We follow the design standard. The design has been completed. You're going to implement this year. Now, what are the design challenges for this undersea tunnel? We cannot have longitudinal tunnel ventilation because it's under the sea, right? This is a challenge. So rescue vehicle basically all have to consider. This is a full tunnel M&E facility. We use a full transverse ventilation. It's only one tube. One tube with the upper deck and lower deck. Actually, it's almost the same concept as the SMART. But the SMART, because it's a road tunnel, in the city, you can have ventilation shaft. For this, you cannot. So therefore, we use this basically ducted using motorized fire damper. Okay, these are the M&E provisions. I will not go to the detail because you can read it in the souvenir book. Two functions of the tunnel ventilation system, okay, to extract pollutant, to control smoke. The design fire size is 70 megawatt. The design fire size for smart tunnel is 20 megawatt. We will not allow heavy vehicle goods to go through, but this one we allow. We allow heavy goods vehicle to go through without combustible material. My company can do a full CFD analysis, right, in-house. And because of our experience now, 80 tunnel worldwide, I have just set up my firm in Australia. I'm going to get my first tunnel job in Australia. This is a tunnel ventilation system. Okay, upper deck. We use an air quality monitoring system. I have ended my presentation, but I want to highlight my experience. Now, because I have done project in 16 countries, I have understanding of various design code in different countries, like Vietnam, it's a French code. You know, I've done project in China, China code. I've done project in India. Actually, I was the design reviewer for the Chenani Nasri Tunnel, the Jammu Kashmir Tunnel, 9 kilometers long. Leighton UGM Port over Leighton, engaged my company to do a design review of the tunnel. I'm currently now also doing some review for some tunnel here. So basically, I just want to highlight that we are here ready to impart our knowledge to whoever want our input. Thank you very much.
Thank you, Mr. Iyer Chansok, for very vividly capturing the details of the presentation and maintaining the timeline. Now I invite Mr. Lukas Rasoknik to kindly take the stage.
Mr. Lukas Lakosnik is a senior consultant currently working with Satra Sport SLO, and he has a degree of MSc of Education, and his membership in professional societies and associations are ITA COSOF and Activity Group 4 Tunnel Safety Officers and PRC TC 4.4 Working Group 1 corresponding member. He has practical experience with urban road tunnels, design, emergency response planning, operation, maintenance, and inspections. Please welcome Mr. Lukas Rakosnik.
Okay. Thank you, Namgo, for your kind introduction of me. Hello, everybody. I'm still happy that you are still here in the late afternoon. I would like also to thank the organizers for inviting me. And now I will give you brief information about controlling of the tunnels in the center of Prague. So as first, I would like you to introduce the location. So tunnels are located in Czechia, in Czech Republic, which is in Central Europe. Its area is about 78,000 square kilometers. It's about 1.5 more than Uttarakhand, and it has 10.5 million inhabitants, which is 1 million less than Uttarakhand. The city of Prague is the capital of Czech Republic, and it will be also the venue of the next PIARC World Road Congress, which will take place there in October of this year. Prague has 1.3 million inhabitants, so in comparison with Dehradun, it's 300,000 more, and its land area is almost 500 square kilometers compared to 200 square kilometers of Dehradun. Well, on the left you can see the main road network of the city, which consists of 2 ring roads and 7 radial roads. As you can see, it is in several stages of design or operation. So the city circle is operated with 22 kilometers of the total length of 33 kilometers. So the jurisdiction and administration and management of the main city network is as following. The Prague Highway Ring is administered by the State Ministry of Transport. Road and Tunnel Manager is Road and Highway Directorate of Czech Republic. And the city circle and the radials are administered by the city department, and Road and Tunnel Manager is a company named City Technical Administration of Roads. The tunnels in Prague, we have the largest one on the city ring. It is Blanka Tunnel Complex, which was finished in 2015. Its length is about 5.5 kilometers, and it is divided into 3 sections. It has several ramps going on and out. To the south, it's followed by Strahovský Tunnel with almost 2 kilometers, and then after some surface section, we have Mrazovka Tunnel, 1.3 kilometer, Zlíchovský Tunnel with almost 200 meters, and in the center of the city we have some older tunnels, Letenský and Těšnovský Tunnel. On the highway ring we have also tunnels, Lohkov Tunnel and Chloupice Tunnel. In Prague we have 3 control centers. The first one is control center for technology. It is Strahov Control Center, where City Technical Administration of Roads for the tunnels is situated. Then in the city center we have main traffic control center, where the traffic for the central part of the city is operated by the state police. and the tunnels on the highway ring have its control center Rudna, where the tunnel operators and traffic operators are in one control room. So we have the same team operating the tunnels and network in the center of the city, and the same traffic operator team of police operating the highway ring tunnels. We have also aim for the future to merge the city center control centers into one new multifunctional operation center, Malovanka, where also the operators of technology and traffic operators will be situated in one room, and where also during crisis the state police operators, city police and fire brigade and rescue services operators will have occasion to share this control room too. The aim is similar to the idea of Brussels Control Center, of the new Brussels Control Center, and among all I would like to mention new open architecture solution, enhanced cybersecurity. We are looking to reduce the vendor lock-in in the technologies, and of course in communication we would like to simplify and accelerate the communication between tunnel and traffic operators, and also between emergency services. The actual state is that the building is under construction, and we are working on design of technological equipment, and we are working on plans for functionality transition from existing control centers. Now back to the tunnels. For the rest of the presentation, I will focus on only on the tunnels on city ring. Each tunnel has its own control system. Each control system is divided into two main subsystems for equipment control and for traffic control. The tunnels and nearby access routes are covered with traffic telematics as usual, and because the tunnels are near each other, we have the whole telematic section length about 11.5 kilometers on the city circle. So each tunnel can be operated independently, and of course each tunnel reacts to its neighbor, but unfortunately we still don't have any supervisory traffic control system which will take the traffic management a little bit holistically. In default state, the controlling of traffic and equipment is fully automatic. Our automatic incident detection system is based on video detection, and of course the tunnels are equipped with fire detection systems. As the alarms of control systems has severity classes as usually, and detected incidents in the tunnels are then filtered, and the operators are given only a little small amount of alarms. Yeah, so let's move on. A few comments on SCADAs of control systems. clear description of tunnel layout is needed. Distribution of elements in SCADA must correspond to actual distribution of elements in tunnel. Then same schemes for everyone involved must, or we need to have same schemes for everyone involved, just to have one unified language for all the stakeholders in communication and interventions and so on. And yeah, it is necessary to precisely locate it, the incident in the tunnel, and it is also crucial to set the right way and intervention route for emergency services coming to the tunnel. Actually, in Prague, the SCADAs differ in some aspects depending on when the tunnels were realized. But we expect it to be unified during following renovations. Well, so main goal is for me to tune the technology and control systems to demands and capabilities of emergency services and operators. Just to give you a free rough idea of the number of incidents dealt with by operators during operation, here you can see the figures for Blanka Tunnel Complex only. Well, it's divided into directions and into 3 sections, but in sum I can tell you that in last 7 years we had some 15 fires, and we have about 100 accidents in 1 year. Please still remember the tunnels are heavy trafficked, and yeah, this is the situation. Of course, most of the tunnels have impacts to tunnels availability, and of course during traffic peak the incident in one tunnel will cause problems in the rest of the ring tunnels in several minutes only. Well, coming into the tunnel safety and the concept, yeah, we are following the topic of hot new topic of PARC, the resilience strategy, or let's say anti-fragility strategy. So it's handled like follows. Road and tunnel safety accept level is based on several pillars, as you know, based on construction, technological equipment, of course on controlling and maintenance and emergency response. So when incident occurs, it's a sudden impact, and always we can expect some new uncertainties and new circumstances and findings. For example, coming from human behavior and so on. So after incident, we have to make an inspection and investigation, and on the basis of this inspection and investigation, we make recommendations. Then you have to recommend some measures and so on. Then usually follows the negotiation process with tunnel manager, and so. And after, yeah, we are still focusing on a low cost and low time solution, so it is not expensive and it could be implemented in a very short time. Well, this is an example of one of the solutions from Blanka tunnel complex. You can see it's divided into 3 tunnel sections. So when, for example, incident occurs, then the reaction of the system for the fire sequence is as following. It means that we close the entrances to the tunnel from the entrance. We close the section with the fire, and we close also the opposite tunnel tube, but we close the sections where the evacuation process will follow, as we hope usually. And so the traffic flow is led to get out from the tunnel if it is not involved in the incident. And the solution was for traffic management, and we also added these blinking lights for the firefighters, so it's aimed to identify the right emergency egress which firefighters should use for intervention. Because we had, even if we had training of the emergency services and we are trying to make them familiar with the tunnels on a regular basis, we had several situations when the firefighters missed the right egress, and it took a time to solve the incident properly then. Well, so we closed the tunnel. I will close my presentation. So thank you very much for your attention, and I'm ready for your questions. Thank you.
Thank you, Mr. Rakosnik, for a very comprehensively covered presentation. So we have come to the end of the session today. All the speakers have by and large adhered to the timeline. We have got quite a bit of float here now, so we can open up the floor for question and answer session now. So kindly introduce yourself.
Hello. I'm Dr. Insipal, Engineer Chief, PWD Odisha. My question is to Arthur Kabuya. In his presentation, he said that the first case that for the rehabilitation, maintenance and repair, it was given on a PPP mode.
Yeah.
But there is no details of that PPP arrangements. Can you a little bit brief about that PPP arrangement? If the developer was also assigned the design of rehabilitation, its implementation and operation monitoring, and for what period of the concession, what is the funding pattern between the client, developer, and who was the independent engineer reviewing the work of this PPP assignment, and what is the concession period?
If I understand your question is about PPP model of Tunnel Anicordi, why we did PPP?
Exactly. Why you give it in PPP?
Yes, okay.
And the model, and brief about this model.
Yes, okay. I tell you in my presentation, we had a lot of problem of civil engineering about the concrete, and we don't know really the state of the tunnel in that time. I tell you, during 47 years of existing of Tunnel Anicordi, we did not good inspection. Maintenance was very, very bad about the structure, and the mode of the construction of the tunnel, we have a lot of doubt. And for this reason, we don't control the civil engineering, the decision of our government with the advice of our consultant was to put the tunnel in PPP in order to transfer the risk of the construction to the private partner. The real reason is that we don't know the situation of the tunnel. But now, for other tunnels, like Béliard Tunnel and all other tunnels in the Brussels, we make a lot of inspection, visual inspection, and also complementary inspection. We analyze contract and so on. We know now the situation of the tunnel. For the other tunnel, we will use the traditional model. The big reason is we don't control the situation of Anicordi. That's why we go to that model of PPP.
Thank you. I have the question to Saichok, who presented on stormwater management in the tunnel. And in one of your slides, you have said that your team also did a computational fluid dynamics CFD analysis. Can you a little bit brief about that? What sort of CFD was done? Because it's a single tube with upper and lower deck, and there's a stormwater problem of certain fluid pressure. What sort of CFD and modeling was done? Was the Navier-Stokes equation used? And what sort of numerical modeling carried out?
Basically, the CFD is to analyze when we size up the fan, right? Make sure it's correct size. We do not want it to be oversized, and then it causes a danger to the people, the car. So the simulation actually is to confirm. Normally you do a manual calculation for all the sizing, especially the fan. This is more of the ventilation. So we size up correctly, then do the CFD modeling to model the actual happening. And also, when the fire happen at certain position, we have to model it so that we know how the fire flow. So the position turning off, how long you on all those is actually a computer modeling. All is set. Yeah.
More questions?
My last question is to the last presenter who gave in a good matrix table from 15 to 22 what the type of things happens that has occurred from smoke to fire to even number of animals that are trapped. And I think in one of your slides you have said about 200 odd animals trapped in the tunnel. What type of animal they are typically?
Well, we had several kinds of animals, from, let's say, dogs and cats until foxes and so mainly dogs. We also have some dogs and so, and dogs with puppies, and yeah, it's a long story, but it's a little bit problem because, you know, we have several incidents coming from these situations, and We also had one fire from the situation where the car was just going or was trying to move along the tunnel and to miss the dog.
So if there are no more questions, then I would request my fellow co-chair here, Mr. Namgu Kim, to kindly sum up the proceedings of the session.
Really, do you have no question? Another? Please go on.
Hi, and my name is Randall Cable. I'm from South Africa. I got a question. It's for you, Arthur. You spoke about the mobility manager that you introduced as part of the upgrade of the Transport Management Center.
Yes, yeah.
Is it possible to just expand a bit on the function of the mobility manager? Is it limited to only inside the tunnel or the vehicles coming into the tunnel as well?
Mobility manager.
Yeah, thank you.
Yes. The mobility manager in the control center, his role is to catch information via the traffic analysis system. He have a software for analysis traffic. The purpose is to have the plan of management of the traffic in the town, because we have a lot of congestion in Brussels, and we need to manage the traffic in the tunnel and also in the open surface. And for that, we have a computer head for the traffic management. This computer works with the traffic lights and so on, and with the computer, we can make the policy of traffic in Brussels. And it's an adaptive system with the traffic manager is, I can call the brain for collecting data, analyze data, and after analyzing data in specific software, we have the scenario, and the scenario, we push the scenario to the system of management of the traffic. And also, as you know, we are in the phase of refurbishment of the tunnel in Brussels. The traffic management is a very strong criteria to define which scenario we can use during the renovation work for partial closure of the tunnel during the renovation or total closure. That decision are taken with the help of traffic management. The politicians in Brussels don't like to close the tunnel. Thank you.
Thank you, Arthur. Sadly, it is the last session of this conference, but happily, we had a great time here, and we shared knowledge, and we exchange ideas with each other. So I hope this kind of event will be the good chance for all of us, good chance of cooperation and development. Thank you.
Some of the proceedings of the session. Would you like to sum up the proceedings of the session? Would not? Okay. All the presenters have been very dutifully and very exhaustively brought out their points of views. The moot point that we'd like to put forth is that this entire session, the international seminar that has been convened here, it has been very topical, and it was scheduled to be held much earlier, but because of some exigencies, it could not be done. We are in a state of flux as far as implementation of road tunnel projects are concerned. At the moment, probably in India, we have around 50 kilometers of operational tunnels in national highways. Another 100 kilometers are under bidding or under implementation phases, and maybe another 145 or 150 kilometers are at project preparation stage. So I had the privilege of visiting the Norwegian Geotechnical Institute sometime in 2018, and also had the opportunity to basically go around the extensive tunneling system, the operation maintenance, the design, basically the capabilities and the protocols that are being followed there in Norway. At that time, they had around 850 kilometers of road tunnels. So everything said and done in a small country like Norway, but our challenges are quite diverse now. To my understanding, the ecology is much stable there as compared to the ones that we are talking of. We are basically trying to contemplate and plan more and more tunnel projects in inaccessible areas. So essentially, those will have to be in Himalayan terrain or in other segments of the northeastern part where hills and mountains are relatively much younger. So these are fragile geological formations and very sensitive ecologically. So hence what happens is the challenges are also manifold. So in many of the cases we have seen in our context, because of poor planning and poor project preparation, many of the projects initially had to be abandoned, or mid-course corrections had to be basically planned, wherein eventually we were basically facing up spending more than what we had initially planned. So as the old conventional first principle saying goes, that probably we need to put more effort in detailed designing, detailed engineering, and also meticulously planning the safety, ventilation, evacuation arrangements, etc. So all the presenters here have very, with a lot of clarity, they have brought out the importance of all these essential elements, starting from the drainage, then evacuation principles, protocols to be defined for ventilations and drainage arrangements. I hope that these discussions will be properly disseminated, and we still have a lot of things to cover, long way to go, and contractually also we need to firm up our documents. This event has been very fruitful for us and a very good learning exercise for us, and we take it in that spirit. Thank you very much for your proactive participation and making this event a very successful one. Thanks.
After proper discussions, question and conclusion, we declare session 7B a successfully concluded session, for which I heartily thank our chair and co-chair, for which I request Dr. N.C. Pal, Engineer-in-Chief, Works Department, Odisha, to come up and felicitate our chair, Shri Sudeep Chaudhary, Additional Director General, Morth. Our co-chair, Mr. Namgu Kim, PIARC Technical Committee 4.4 member. I would also request Dr. Pal to felicitate our fellow presenters, starting with Mr. Arthur Kabuya, followed by Mr. I.R. Chansai Chok, and lastly Mr. Lucas Rakosnik. I thank all our fellow delegates to give us their valuable time. As we draw this day to a close, we have gained valuable insights into the seminar agenda, and we have identified several objectives and solutions to the challenges at hand. Therefore, we must conclude our proceedings for the day and take this time to reflect upon and comprehend the gravity of the issues discussed and shared. I would like to express my sincere gratitude to the honorable presenters who participated and vividly exemplified the issues. I also extend my thanks to the chair and co-chair for their exceptional skills, excellence, and experience in maintaining the flow of the proceedings. Let us now take this opportunity to congratulate everyone for a productive and conclusive day. I request all of you to retire for the day and refresh yourself with the high tea planned ahead. Following the high tea, we shall have a valedictory session for the guests and the dignitaries in the Vedanta Reception Hall, 5th floor, at 4:30 p.m. sharp. I repeat that there will be a valedictory session at 4 p.m. sharp in Vedanta Reception Hall. Thank you all for being here.